Okay. Namaskar. Welcome to the second day of 1 week online international faculty development program on machine learning and computer vision application research challenges MLCV 2020 organized by the Department of Computer Science and Engineering NIT Silchar under Day-2 3 as training activity with Guwahati University Institute of Science and Technology, Assam. Good morning to one and all present here in virtual mode. Participant, this is to inform you that we will post the attendance cum feedback form in YouTube channel at the end of this expert talk, and it will be available for 10 minutes. As the number of participants are large in number, it is also requested to post the relevant queries. Otherwise, there is a possibility of missing the relevant questions. Today, we have two eminent speakers, Dr. Pinky Roy and Professor Nidhu Sinha. Moving towards our first lecture of the session of Day 2, MLCV 2020, it is my privilege to introduce Dr. Pinky Roy. Dr. Pinky Roy has been working as an assistant professor in Computer Science and Engineering Department of NIT Silchar since 2004. Her research interests includes speech processing, machine intelligence, cloud computing, Indian language identification, and health informatics. She has honored as one of the most distinguished lady alumni by the Computer Engineering Department of Dr. Baba Saheb Ambedkar Technological University, Maharashtra, India. She has published around 50 research papers in international conferences and journal of repute. Now, may I request you, ma'am, to kindly start your presentation. Ma'am, please.
Yeah. A lot of thanks to all the organizers. I am audible? Yes, audible?
Yes, madam, you are audible.
So a lot of thanks to all the organizers for giving me an opportunity to be a part of this workshop. So today to start with, okay, I'll just share. Okay. Can you see the slides? Hello, can you see the slides?
Ma'am.
Slides? Yes. Okay.
Yes, madam.
Yes. Okay. Thank you. Yes. I am going to start. Just a minute. Yes. I want to make it full screen. Okay. Is it okay now? Yes. Today the topic of my presentation is the research challenges and applications of machine learning with special emphasis on deep learning. Is it okay? Slides? Yes, Naresh, is it okay? The slides? Hello? Yeah. Okay. So since this workshop is going on from yesterday, so I think the viewers had a lot of idea of what is machine learning. But to start with, I'm just going to give you a little bit introduction of what is machine learning. So as we know, the learning is any process through which a system improves its performance from the experience. So we know that human beings also will learn from the system, we learn from the environment, and then we from that experience we gain our performance. So the machine learning terms, actually, since we deal all with algorithms, so machine learning, it basically we study the algorithms that improves the three parameters. First is that it improves the performance P of a system, and at a given task with a given experience. So suppose a task is given to us, so we need to improve the performance of the system, and the performance increases based on the experience it has gained. So a well-defined learning task is usually represented by P, T, and E. So performance, the task that is given, and as well as what kind of experiences it has learned from it. So the difference between the traditional programming and the machine learning is that in the traditional programming, in the computer, data and the program is given as the input, and we get the output. But in the machine learning, what happens is the data and the program is data and the output is given as an input to the computer, and from that the program is generated. So here I'm going to discuss some of the common applications of the machine learning that we usually it is applied in the vast area of fields. Like the ML is used where we can say that the human expertise does not exist, or human beings cannot go there. Suppose it is navigating on the Mars, where we can install a satellite where the ML algorithm is there, which is working, and it is doing the proper navigation of Mars, that whether the human being can stay there, live there or not. Various possibilities it keeps on searching from it. So human beings cannot explain their expertise. So speech recognition is another field where the ML is very much widely used. So it is also my area of research. Then models can be customized, like personalized medicines, like supply of medicines and other things. It can also be there. Also, we can use the machine learning algorithm, and where we have a huge amount of data which is unable to process by the human beings. There also we use the machine learning. So it is known as genomics. So there is a term that learning is not always useful. Suppose I want to calculate a payroll, or I want to do something in the Microsoft Excel of calculation, a normal calculation we want to do, addition of suppose 5 things. So there we don't need machine learning. So machine learning is required where the system has to learn from the experience, and it has to apply where the data is huge. But we cannot apply learning everywhere. So here is one classic example of machine learning. So here we can see here is that we need to recognize the two. So it's very hard to say which one is two here. So here, since it is very difficult for a human being with a huge amount of images to find out where it is two. So so in that case we can use machine learning. So it is image recognition of the letter two. So some more examples where we can use the learning algorithm is that recognizing the patterns. Suppose we want to recognize the patterns of the facial expression, or handwritten digits, or the spoken words, where we have those speech recognition comes into picture, or the text to speech comes into picture. There we can use the machine learning algorithm. Then it is widely used, machine learning is widely used in the medical images. Then it is also used for generating patterns. Suppose I want to generate patterns or a motion sequence for a moving car or in a game, then we can use the generating patterns. Then recognizing the anomalies. So sometimes when we use the credit card or the ATM card, then sometimes there is unusual credit card transactions, or somewhere when we open the Google Mail, if we are opening it from a location which is not from our location. Suppose we are going to Singapore or some other place, and I am opening my email. So it will keep track of the location, and it will give us a reply through automatic machine learning that since the person has changed the location, so maybe some anomaly may be there. Sometimes it helps us to catch the real anomalies also. So unusual patterns of sensor reading in a nuclear pattern or nuclear power plant. So sometimes if there is some unusual error or unusual pattern is there, that also can be recognized. So it can also be help us to predict the stock exchange price or currency exchange rates, or the very common we use it for weather predictions. So there are many such applications. It's a huge application field. It can be used in the financial organization. It may be used for e-commerce, for better selling of the products, better advertisements, space exploration. Then it can be used in the robotics for the robot to move and perform better. Then it can be used for extraction of information. So we can extract the proper relevant information from a given data. It can also be used in the social networks, like in the Facebook we are using, or any other social networking websites. It is used for better working of the software and debugging software. So these are some of the sample applications, but this is not limited. The machine learning can be used. It is having a wide area of applications. So going to now the technical part, how can we define the learning task? So if we want our task to improve with respect to the performance metric P, and based on the experience E. So that is our main task. We need to improve the task, and we want to improve the performance metrics, and based on the proper experience. So we human beings also learn like that. So we make the machine also learn in the particular way. So suppose there is an example, some 3-4 examples we are talking about here. So here, suppose my task is playing checkers game. So here the performance, how I will fix out, we will fix the performance based on the performance of the games, percentage of the games won against an arbitrary opponent. How much number of games he has won, and how it will improve the experience by playing practice game against itself. Like if we are given the task of recognizing the handwritten digits, then the percentage of the words are correctly classified will be the performance metrics, and how it will learn from the experience based on the database of the human level images of the handwritten words. So that experience is already available with the system. So based on those database, the system will automatically learn, and it will give the performance. Then task here is to drive on the 4-lane highways using the vision sensors. So that is the main concept of a driverless car. So here, how the performance measure will be measured based on the average distance traveled before a human judged error. So whether there is an error while it is going to judge the cameras that are located along with the driver's seat. So how it will learn for the experience, a sequence of images and the steering commands are recorded while observing a human driver. So how it will do is that it will try to collect the images and the steering commands. It will keep on recording that how the human driver is driving the machine. Based on that experience, it will learn, and then the average distance traveled will be the performance metrics. Then categorize email messages as spam or legitimate. So this is a very common thing we can see in our inbox, that how we are categorizing the email as whether it is spam or legitimate. So here a machine learning plays a very big role. So it will check that the percentage of email messages correctly classified. First it will check. Then in the for the experience, it will keep a database of email, some with the human given level. So suppose it will we have labeled some of the emails that that is a spam category. So if it is spam category email, then what we can do is that we can it can automatically go to our spam folder, and by that it will keep on um, improving the performance metric of the system. So, if we go to the deeply that how the state of art application of machine learning is actually applied. So, first we can see that in the autonomous car here to the images how it is applied. So, maybe in India it is not yet legal, but in US and many other countries, the autonomous car has become legal. And autonomous car, it is also very commonly known as your driverless cars. So, in the driverless car, what happens is that there are various cameras which are located at the front end, at the top of the car, and it will keep on locating the images based on the sensors which are located along with it. So there are various sensors of the car which is located. So here we can see there is a stereo camera which is located here. And these two things, there are two ladders which are located here, which will help to detect the obstacles that it comes in between. And here there is a 360-degree 3D ladder, which helps us to find out that obstacles are from the four-sided or not. Three-sided, it will keep on checking the obstacles. And there is a GPS, which is located at the back end. So these are the devices which help the driverless car to move in the forward direction. And there is an automatically, it will keep on storing the data that the human driver will have to follow while driving the car. So here we can see that autonomous car technology here, this is the laser. So laser terrain mapping. So it will keep on mapping the distance through which it is going to travel, and it will keep on planning the path maybe 5 minutes before or 10 minutes before going to that path. So here it will see that whether there is any obstacles is there, how to make the path while going through the some terrain path. So it will keep on doing the path planning beforehand. So this is an example of an adaptive vision which it will create before the car moves through that portion. So this is how it learns from the human driver. So here one graph is there which shows that how accurately it tries to learn from the human drivers. So now from machine learning, I will just go a little bit deep towards the deep learning. So deep learning, it's a major headline which is now carried out in everywhere. So people are now much of all interested in the deep learning, and big software industries like Lee, Microsoft, Facebook, Google, they find themselves in a battle for deep learning talent. So in the Microsoft and they have a lot of experts that they work with the various deep learning algorithms. And in this age of robots, where we have to handle with a huge amount of data, we have to be very particular about what kind of algorithms we'll be using. And deep learning, it's a very common technique which nowadays we are using to handle huge amounts of data. So very famous companies like Google, Microsoft, Facebook, Lee, they are all using the different kinds of deep learning algorithms. So if we have a huge amount of images also, from that images also object parts, the system can easily learn. So this is an example of that how through the multiple objects, suppose cars, faces, motorbikes, airplanes, we have different images through which the system can learn easily. So in the machine learning can be easily applied in the automatic speech recognition. Here, how we are recognizing is that initially we extract the features then any software algorithm can be used, classification algorithm like neural network or I have to, please excuse me, someone. I will just take break for a second.
Yes, sir. Pinky ma'am? I think so. She has technical problem. Pinky ma'am?
Yeah.
Pinky ma'am?
Sorry, I was disconnected.
Okay, ma'am.
Just
Okay. Okay.
Just okay. So we are talking about the machine learning in the automatic speech recognition. So we have a typical speech recognition system where we extract the features and then we can use the various classification algorithm we are having. So here one example, the neural network, that from that we decode the system and then we put it into the transducer and the language model. So machine learning is used to predict the phone states from the sound spectrogram. So this spectrogram, something it looks like this, the voice that is recorded, and these are the signal representation. These are the spectrograms, and these are the signal representation. So here, wherever these red signals are there, that means here the congestion of the signal is more, means speech data is more, and here there is some silent speech is there. So based on that, there are either we can use neural network or various deep learning techniques can be used. Gaussian picture models can be used. So these are various classification algorithms that can be used in the speech recognition. And here the example is given for the word hi, how are you? So as we know that speech technology, it's a very growing technology that is nowadays used. In the mobile phones also, we can, through speech, we can search the words. In the Google also, a lot of research is going on the speech so that lot of friendly applications can be made. The lot of speech technology research is done. The reason for it is that it will be very easy to use the system instead of typing and all those things. Anyone can use the system very easily. So there is a lot of research prospects that we can have in speech technology. Now coming to the technical part, we have different types of learning that we have in the case of machine learning. So there is a supervised learning. In the supervised learning, which is also known as inductive learning, the training data is already given and along with the desired outputs. So the data is already input to the system with the given output levels. So supervised learning can be easily compared to the classroom teaching that we give to the students, where uh, we already train the students, then we know that these are the grade category that we are going to give to the students. And based on that, if a student is not performing well, then we keep on taking the summer term, winter term, then improvement test or training the weaker students. So this is our training part. So if he does not meet the desired output level, we keep on retraining the student. So that is an example of a supervised learning that we can relate to. Unsupervised learning, here the training data is given, but without the desired outputs. We don't know what the desired outputs are there. So sometimes when we do the research as a PhD student, when we have done, or the scholars when they do uh, their research survey, technical survey part, then during that time, maybe they don't know actually before fixing up their research topic that what kind of work they're actually going to do. But they keep on surveying the research papers and other things until and unless they don't come to a proper topic that they want to do. But the training process or learning process keeps on going on until and unless they come to some desired or some required uh, output which they themselves does not know that what they are going to do. So that is a very good example of your unsupervised learning. Then we came to the semi-supervised learning. In the semi-supervised learning, the training data is given with a few desired outputs. Okay, so training data is already there, but the total outputs are not given, but few limited desired outputs are provided along with it. And in the reinforcement learning, there are a common sequence of actions that are there, and the rewards are given for that proper sequence of actions. So an example here is supervised learning. This is a regression example. So how we are going to predict based on a supervised learning. So this is an example that is given here. And here it is a supervised learning classification of a breast cancer detection based on whether it is a malignant or benign. So this is the size of the tumor. So here this is a benign size and this is a malignant. So it is trying to do the two-way classification. So here also it's the same thing. So here we are trying to predict whether it is a benign tumor size or it is a malignant tumor size. Supervised learning. So here we can use it for medical diagnosis system, which I will discuss at the end of this lecture in details. So here we can see that clump thickness, uniformity of cell size, uniformity of cell shape. So if there is some abnormal cell shape, so we know that that is an example of your cancer. So red one shows that there is an abnormal cell size, and the blue one shows that it is a normal one. So we are doing a proper classification, which is known as a linear classification based on the supervised learning. So that you can say that that is an output of the supervised learning, where there is a difference between benign tumor and the normal one. So, so here it is an example of an unsupervised learning. So it's somewhere we have a lot of lot of labels, or these are the input data that we have, and this input data need to be labeled and it need to be categorized. So here we have categorized into three different parts. So one is benign tumor, one is malignant, and another one is your normal one. So these are the three different colors that is given to classify that we are having three different classes of unsupervised learning parts. So here another example of unsupervised learning is that suppose we are having a group of clusters where we want to store the data. There we can do the grouping. So unsupervised learning, indirectly it is a grouping of the clusters into different parts. And this is the social network analysis. So in that we know in the Facebook that if I am the friend of someone, then his friend also comes a suggestion list. So in that way we keep on linking. If I like someone posts, so everyone in my group can see it. So how it is done is that if I am the person who is accessing the Facebook and I am doing something, then whoever is linked with me in the Facebook, all of them comes to know with the notification, all of them can see the data. So here, all this social network analysis also, unsupervised learning is used, and the network is made with this. So these are my friends are linked with this group of friends, this group of friends are linked with this group of friends. Ultimately, all are in the network. So in the market segmentation also, the people who are doing the different same type of thing, they can be usually segmented and they can be usually grouped. In the astronomical data analysis also, the unsupervised learning can be easily used. So here another example where we can, in the unsupervised learning, where we can scatter the two different types of data spoken by the two different types of speaker in a proper crowd. In a crowd, suppose two speakers are announcing something. So using our unsupervised learning technique, we can recover what speaker one has told and what speaker two has been telling for a long time. So we can easily do it using unsupervised learning technique. So here independent component analysis is used. So here we can see that ICA is used here, and then we are recovering that. So reinforcement learning, coming to it. So these are the different states and the action with the proper rewards we are giving the output policy. So some common examples we can say is that credit assignment problem. Suppose when we give any assignment to a student, we assign a particular credit to it, particular points, particular marks to it. The same way the reinforcement learning also works. Once it learns, we assign a particular credit to it. So reinforcement learning can also be used in playing games. There also we assign a particular credit and the game keeps on improving. Suppose level 1, then it goes to level 2, level 3. So the user also enjoys, usually children enjoys a lot when they play the game because of those credits that are assigned during playing. Then robots in a maze, then balance a pole on your hand. So these are different types of games that we play. So where we can use the reinforcement learning. So this is an example, very common example of game playing. Okay. So how, after going through all this thing, a question comes in our mind is that how we are going to frame a learning problem. So before designing a learning problem, we need to first see that what kind of training experience that we are going to choose. Then choose exactly what is to be learned, that what is the target function that we want to achieve. Then we need to choose how to represent the target function, how we are going to represent it, and then choose a learning algorithm, or what learning algorithm we'll be using to infer the target function from the experience. So this is my environment or the experience from which the system is learning. So here this environment and experience we can replace with the database that we are going to provide it. And then this database is going to be trained and it is going to be tested. So once we are training the data, during that time, there is a learner is there. The learner is trying to take all the training data and it is trying to learn from the system. And while getting the training from the database environment experience, there is a knowledge database also that is available. From there also it will learn. And after that, during the testing part, it will compare that whatever it has learned from the system and whatever the experience it has done, so whether it has learned properly or not. So during the testing time, that can be done properly. So usually I give in the classes also the very common example through which it's very easy to understand how a learning system works. If we take the example that learner is a student who is trying to learn from the knowledge, means books that he is having, and these are the environment or the experience, means whatever the teacher is trying to teach in the class from the different maybe the books or other things that is available on the internet, he is trying to run from it. And those training data, the student is trying to learn. And testing is during the exam time, we are testing through different books, through different question papers, assessment, class test, and all those things. And whatever the result he is doing, that is the performance element. The same way, the system is also learning, but the parameters are little bit different. So here the learner is our computer system. Knowledge is whatever the data we are feeding it to it, and here it is the database. So now how to distribute the training versus test distribution. So if you can see here is that whenever a bigger database is there, we need to divide it into two parts. One is in the training data, another one is the testing data. So training data is always 80% and testing data is usually 20% or 30%. So training and testing data is usually divided into either 80-20 or 70-30. So So after that, based on that, we are going to distribute the data. So if we see what is the machine learning in a nutshell, so there are more than 10,000 of machine learning algorithms that are generated every year in the various fields. So it's a huge area which is used not only in computer science, it is used in every field that can be, it can be e-commerce, business. We have seen that it is used finance, marketing, share market, everywhere it is used. And so many applications are there, and based on that, hundred thousands of algorithms are made each and every year. So ML algorithm is having the three main components. First, we need to represent the data, how we are going to represent. Then there is the second step is we need to optimize the ML algorithm. We need the different optimization techniques through which we are going to optimize the algorithm, and then finally we are going to evaluate. So these are the various representation of the ML algorithms. If we want to represent the ML algorithms, this representation part, if we want to represent the ML algorithms in numerical, suppose my data is in the numerical part, so best way is that we can use the neural network for that application, or SVM classification algorithm for that application. If it is in symbolic, yes, no, or small letters, it is there, true, false, like that, then we can use for representing, we can use the decision trees. And if it is an instance-based thing, then we can use the nearest neighbor algorithm for representing the ML algorithm. Now, these are some of the examples of the optimization algorithms that we can use in the machine learning. So, gradient descent. In the gradient descent, there is a perceptron and the backpropagation algorithm. These are the different optimization technique we can use. In the divide and conquer algorithm, we can use different rule learning algorithms. And in the evolutionary computation, we can use different kinds of genetic algorithm which are available to optimize it. Now, these are the various evaluation techniques that we can compare with the student evaluation techniques we use. The same way in the machine learning, we use the various evaluation techniques, or we can say the testing mechanisms we usually use. So accuracy is either we can evaluate it through measuring the accuracy of the system, which can be measured by number of correct predictions divided by number of total predictions. Then we can measure the square error, where the true false positive is minus predicted value to the square, and we can find the total error. And another one is your confusion matrix, through which we can find out the true positive, true negative, false positive, and false negative. So this is the matrix we usually generate. Now, after the machine learning, so many introduction, learning and different parts. Now I'll come to this deep learning techniques. That is now I'll come to the deep learning techniques that we generally use. So nowadays, the deep learning, it's a very common technology that is nowadays used, and we are much assured about how to use the deep learning technique in our day-to-day life, and or maybe in the different algorithms that we are going to apply in our work. So deep learning, it's a new age technology algorithm where there is a high dimensionality. Temporal dependence means when the data is very huge, then the normal machine learning approaches fail. We can't use those approaches. So in that situation, that you see, this is a machine learning technique, and deep learning works inside it. So deep learning works when my data size is too big and it's very difficult to handle using in a common neural network or SVM technique or any other common machine learning classification algorithms. During that time, we need to enter deep into the system, and then we need to apply different deep learning algorithms then to make the system efficient. So here we can see that the reference. Here is an image. A person is sitting, he's extracting the features, and then he's giving to the machine learning system. The machine learning system is classifying based on maybe NN, SVM, or other techniques, and the output is usually generated. So then we can find out whether the person is having cancer or not. Maybe it's a cancer detection algorithm. But in the deep learning algorithm, what we can do is that the image can be given as input to the classification algorithm, and then we can get the output whether the person is having cancer or not. So in this deep learning one, the system is doing the whole work without a human intervention. The system is going to do all the work inside the system. So deep learning neural network, it is similar, it's very similar to a neural network system, how our neural network system works. In the neural network, as we know, we have an input layer, we have an output layer, and in between we have a hidden layers. But in the deep learning network, the thing is that it's very much, it's a mini copy of neural network, but the difference is that in the deep learning network, this number of neurons may be very huge, the hidden number of neurons. And the main idea of deep neural network is to manage this huge layer of networks which are located between input and output. So you can see this is an example of your convolution neural network. So here also, here we can see this is an output volume, 401 output node, and this is a fully connected neural network layer 3, neural network layer 4. So here, this is an image that is given as an input, and this is a convolution network 1. So it's an example of a big network that we are using. So coming to this one, okay. Coming to the DL algorithms. So here I'm going to discuss the very popular DL algorithms. Here it is the LeNet convolution neural network, deep learning algorithm. So here we can see it's a 7-layer convolution neural network. So here the main idea is repeatedly it is using the convolution and the pool layers, and it is using the hierarchical features from the input images. So here it is a very big input image, 28 into 28 input image, and here it is after extracting features. This is the 16 is the measure of the features. So 28 into 28 into 16 matrix it is making, and then again it is reducing to 14 half. Then convolution 2 it is giving to 14 into 14 into 32. This is feature set is again increasing, and here again in the pole 2 again it is reducing. 14 is reducing to 7. So now it is coming to this, and these are the feature maps that we are using, and finally based on that we are getting the 10 outputs. So here our main aim is that if we have a big input data, we need to convolute it, and then we need to pool it, and then we need to reduce it, so that the data that we are using, it keeps on reducing, and then feature set is increasing. Why we require the more feature sets? Because the features define that how we are going to recognize that image or recognize the system. Suppose an image is having a lot of features, like what is the size of the face, how the nose is there, where the lips are located, what is the color of the eyes. So these are the important features we try to locate while recognizing an image. So we need a large number of feature sets so that our recognition is proper. The more features, the more the recognition is proper. Okay, but the data set that is given here, 28 into 20, so this here, lot of unused data or unused things are there which we need to reduce and increase the number of feature sets, so that finally we get an output which is very good for classification. So here it's another popular DL algorithm. It is convolution neural network algorithm. It was introduced by Jeffrey Hinton Group. So it won the ImageNet challenge also. So here we build a deeper network by stacking many convolution and pooling layers. So here we can see. So there are a lot of pooling layers. So these are the actually inside pictures. This is my input, this is the output. And as in the neural network, we have inside the set of layers. So since in the deep neural network, the problem is that we have the huge data set as input. The input is very huge. So since it is a huge, so it should be managed properly inside. So it should be managed properly inside. So we have different kinds of DL algorithm which we use for proper classification of the system. So how we do the classification? The classification is mainly based on the database that we are actually accessing. So here it is divided into 2 parts. Then again it is divided into 3 parts like that. It is made smaller and smaller. So another popular DL algorithm is your GoogleNet Inception CNN network. So here we can see one example is given. So here different size filters of the same layer is introduced. So here we can see how those layers are managed inside and how we are getting the final result. So this is one VGNet. This is a very popular convolution neural network for deep layer algorithms. So it consists of 16 convolution layers. And here the main idea is that it's an image that is there. From there we take an image, then convolution 1, 2, 3, 4. We keep on making it until unless we get the resulting output. So in this case, we can see that the more we will go into deeper as per the VGNet, the more better accuracy we are getting. But the disadvantage of this kind of VGNet algorithm is that it makes the system very slow. Sometimes it takes 3-4 days to give you the result, and since the performance becomes less if it takes more time to give you the output. Otherwise, this policy is very good. So to come up or to cover up with the negative points of this VGNet, another popular DL algorithm come into picture, which is known as your ResNet convolution neural network. So in the ResNet convolution neural network, what happens is that it keeps on jumping. You see that here we are having a set of the things that has been made, full of things, and then it can recurve, and then it can jump from one system to another. So we can see that it is jumping from one system to another. So what is happening if it skip connections sometimes to avoid the layers? So it is also much deeper than VGNet, but sometimes it is less complex because it can sometimes skip the connections if it is not required. So here you can see we can skip it. Suppose this part is not required, it can be skipped. Okay. So, but in the VGNet, it has to go through all the layers. So that makes it little complex. So here, to make it little easy, the ResNet convolution neural networks helps us to jump from one layer to the another layer. So in the DenseNet convolution neural network, it was introduced by Huang et al. In 2018. So here we can see there is a lot of dense connections are maintained, and the input, suppose a horse is given, and this is the convolution network. This is a dense block. Then convolution, this is a pooling. Then we have the dense block 2. Then again pooling. Then dense block 3, and finally it is going to predict whether this is a horse or not. So it is concatenating. This dense block 1 to 2, 3, it is concatenating. So main idea is that every layer has access to all the feature maps that is coming from the preceding layer. So this layer is having access to this layer is having dense block 2 is having access to the layers. It is coming from dense block 1. Same way, it will keep on going on. So this is an popular DL algorithm segmentation that we are going through. So In the popular DL algorithm segmentation, so these segmentations are, as we know, when we take an image as the input, we need to segment. Means we need to make it into different parts, small different parts. We need to make it. So this is an part introduced for biomedical image segmentation. One health related some image is taken, and we need to segment it for the biomedical use. So one very common segmentation algorithm for which is based on deep learning is the UNet. Here encoder decoder like architecture is used. So what is done is that it is make into different small parts, and then ultimately it is they are trying to find it out, and different this after the segmentation, it tries to find out where the image is located. So these are the position of the image that it is trying to do. So we can another popular DL algorithm segmentation, deep learning. It is known as your fully convolution network, FCN. So here we can see this is an image of it is a aerial view, or maybe from the Google satellite the image is taken of a particular place. After using this UNet based fully convolution neural network, where we can use backward learning, forward interference, after the prediction we can see it has made some pixel lines, or it has segmented. So these are the lines, these are the house that we have trying to predict. You see, these are the roads, or this is also a house, and the green one is the road. So here it is now doing the segmentation. That means the red color one is the rooftop of the house, blue color one is the sidelines of the house. So these are also the houses, and the green colors ones are all the roads that are. It's not the road; it's the gardens that are located behind the road, and the violet ones are the roads that are located at both the ends. So this is the way the segmentation is done and various coloring is done, so that now this image is ready to be put to the system, so that we can now do the next part. After segmentation, we can now put it to the system, and then we can use any other deep learning algorithm for the images, and then we can do the classification. So this is an example of your segmentation based on deep learning algorithm. So now I will little bit discuss after going through all this thing, that what are the technical and the research challenges that we have to go through while we work with the machine learning, or we want to work with the deep learning algorithm techniques. Because deep learning, it's a very emerging technique, and people like to work in this area, but there are a lot of challenges that we have to face while working with the deep learning technology. First of all, once we want to work with the deep learning models, the problem is the inadequate training data. The training data that is available is not much efficient, or it is not much available that we can work with it. So DL models are known for handling huge amount of parameters. Yes, the DL model, it can handle thousands of parameters, it can handle huge amount of data. So the thumb rule is that the data required is almost 10 times the number of parameters. Like if the parameter is 10, so it is 10 into 10, like 100 data is required. So if it is 10,000 parameters, then we can say that how much data it will require. So it's a huge amount of data it requires. Then the availability of appropriate amount of data. So we need the proper data for training the DL model, so that it can provide us the proper results. So which is a very challenging task. It cannot be done, because suppose we apply the DL model in some of the examples, suppose financial organizations or e-commerce applications, or we applied into the healthcare data. So sometimes the happens is that appropriate data is not available in that field. And when we talk about the data quality, when we want to work with a real life problem, when we collect the real life data, usually the real life data are unclean. It is not properly cleaned. It is sparse. It is not structured like the sequence of time series or like DNA, audio, video signals. So sometimes what happens is the data that we collect from the original after recording, it's not proper. Suppose if we take the speech data, if we originally record the data and if we take as input to the system, sometimes the speech data is not proper. We have to make it proper before using it. So the adequate domain knowledge and the application of various pre-processing techniques need to be there. So we need to first pre-process the data that we are having. We need to, if it is speech data, we need to remove the noise. We need to remove the irrelevant features that are already associated with it. Like whenever we record any speech data, lot of voices, unnecessary voice, unnecessary data is recorded along with it. We need to remove that thing before feeding into any DL model. If we are working with a healthcare data, if we collect the healthcare data from a local doctor or a local hospital, when we collect the data is not in the way that we can directly take it and put it into the system. We have to remove so many things from this from the data. We have to find out which are the relevant features we need to give to the system, and then only we can handle that data. So technical and the research challenges that we have, handling of the non-static data. Suppose when we work with the healthcare data, as I've told you, suppose I want to take the real-time data of the blood glucose monitoring. It's a real-time data. Suppose blood sugar testing, brain activity signals of real time. So sometimes it becomes very difficult to track the real-time data and take it as it is into the system, and then we had to put it directly to the deep learning model so that it can work. So in between intervention is required. In between the data that is real-time data that we are collecting, we need to make it proper. We need to remove all the irrelevant things from it before feeding into the system, which itself is a very big task. So learning from this continuous data is a challenging task. If you want that our system is learning from the continuous data, suppose a brain activity cell detector is kept and a person is lying there and his brain activity is trying to be detected in the real time, and that data is fed into the system in the real time. So sometimes we don't have that kind of expertise that uh, it will keep on continuous monitoring of what is going on to the brain of that coma patient, and it will continuously monitor and it is give us the data, because the data that we are receiving is not in that proper form that we can feed into the system. There are a lot of issues we had to handle that. Interpretability, the working principle of the DL models are usually it is a black box in nature. As our NN, we know it's a black box inside. So DL is also mostly it is of black box type. So there are many domains where the algorithm should be easily explainable for it to gain acceptance. So and another thing is that to use all those DL approaches, data learning approaches, we require the huge amount of high performance computing units which will help us to process the data. So it cannot be run into a normal system or a normal server. We require a huge heavy server which will help us to compute or which will help us to process those data. So this is a very important requirement of the while working with the DL techniques. So after that, I'm just trying to giving you a little bit overview of my research area that I am presently working on. So deep learning in healthcare and important and emerging field. So as I have talked in my earlier talk that nowadays the healthcare, it is a very emerging field and where we can use the ML techniques. As because of a virus outbreak, as all of we are stuck inside the COVID-19 and all those things, and we can see that how much the health delivery is, people are not able to give those kind of health care delivery. Because of it, many people are suffering and losing their lives. So if as a computer engineer or as a system engineer, we can contribute something to the um, healthcare improvement, then it will be a very big contribution to the society, and we can do that. But maybe it will take time, but we can do that. So deep learning in healthcare, it's a very important emerging field, which I will little bit discuss, and I will little bit give focus on whatever work that I am presently carrying on. So as I told you that before uh, going through the research approach and problem formulation based on healthcare, the first and foremost thing is that we need to find what are the healthcare problems that the society is currently going through. As we can see that our society is currently going through a very important health crisis, which is known as COVID-19. Except that, also we have other health problems like cancer, which is a very common problem. People are suffering. Like we have diabetes, which is maybe one in every four persons are diabetic in our country. Like that, we have to find out what are the common health problems that our society is currently facing, and then which problem, when it is solved, it can help the patient care and it will improve the patient care drastically. Suppose if I take an example of diabetes, it's a problem which cannot be detected earlier, but once it is detected, there is no solution to it. You have to take medicines, you have to be in proper care. But as the doctor suggests that the diabetes, it is a hereditary disease. If your parents are having, or if your lifestyle is sedentary, or if there are some issues with your weight, or many other issues are there, you may be diabetic in future. So if we can predetermine a disease, suppose diabetes, if we can predetermine and if we can help a certain set of population, that if they are pre-diabetic, if they can find out that they may be pre-diabetic, they can do, and some suggestions can be given to those patients, that you can change your lifestyle, or you can work on your BMI, body mass index, or there is since it is in your heredity, so you have to be taken this kind of precautions. And if as a computer scientist or computer engineer, if we can solve that kind of problem, and we can provide a particular app that is available in the mobile, through which a patient can easily go through that app and easily find out that I have done my this testing. I will put it into the app, and if my app is showing it like this, that means I may be diabetic in future. So if I am diabetic in future, then according to the lifestyle, maybe this app will direct to some yoga exercises, or maybe to some uh, health health professionals. If the case is complicated, it may give some suggestions of the doctors, diabetic doctors, to whom he can proceed, or it may give some options of healthcare things that it can adapt it into the day-to-day life, like change in the food habits or change in the lifestyle. So many things that app can give it the solution. So these are some of the ideas that we can give, or we can try to solve, and give a particular we can contribute to the society. So there are so many contributions we can think of, and we can contribute it to the society. So for like that, we can work on the different like diabetes, we can work on the cancer also. We can think of some other solutions which we can help the patients. So, and after thinking of the problem that we are going to address, then the first thing is that we need to study the literature. That what is the literature that is available. Then for that, we need to read the review papers from multiple subdomains that are available from the good journals, maybe from Elsevier or Springer. What other people are contributing into this field. Then after doing the literature survey, doing the technical part, the first thing is that we need to talk to a healthcare professional in our locality and understand the need. The first basic thing is that if we can contribute something to our locality, it will be very good for the society. and we can work with the local people or local doctor in the contribution. At the simultaneous time, we can do our research, contribution to the society, as well as our normal teaching duty. So for that, it's always helpful or always useful that we should talk to the healthcare professional in our locality, and we should understand the need, that what is the need of that particular area, which a healthcare professional can easily deliver it to us. Then identify the problem types with respect to the needs by answering the following. Whether it is a classification problem or it is a segmentation problem. Now, after that, we'll come into the technical part. Then the problem that we are going to access, if it is a classification problem, that what kind of algorithm we need to use there. If it is a segmentation problem, as I have told you, many types of segmentation algorithm which are already available, then we need to find out which segmentation algorithm will fit it to the problem and which classification algorithm will fit it to the problem if it is a classification problem. Then what type of data we need to be analyzed. Suppose we need to analyze the data. Is it a numerical data, textual data, image data, or it is a video data, the database that we are going to use. Then we need to formally represent the identified problem in technical terms. There is a problem is there, we need to represent it into the proper terms, the technical terms. Then after that, we need to set up the experiment and get the data. Then so to build the effective deep learning models, the data acquisition, as I told you, is a very important thing. So some of the healthcare usual data it's available in these are some the repository, machine learning repository, Kaggle's challenges, and University of California one. So here some of the cancer data or some of the diabetes data, like that, many diseases data are already stored in these archives. You can go through it and you can download those data. And healthcare informative literature review papers, if you go through there also, you will get various links of the data people are working through it. So first aim will be that we should work with already whatever the data that is available with us, and then the repository data that is available in the internet. And then after our model gets validated, after we get the experimental results and our model gets validated, then we can take the local data from the local hospitals, we can clean it, we can do the cleaning and archiving of the data of the local hospital, and then we can again put it to the model that we have already tested with the archive data, which is available in the UCI repository. Then we can just remove the data and put the local data which we have collected from the local hospitals, and then put it into the model and see what kind of result it is giving to us. Experimental setup. So we prepared the data for the experimental study, which involves many steps. So as I've told, when we collect the data, there are many issues if we want to collect the original data, maybe from some hospitals and all. So the data is it's very unstructured. So we have to take the raw data, then we have to structure it, that which part of the data we actually require, which part we have to remove. Then we have to do the data pre-processing of the data needs to be done. Then exploring the data analysis. Then we have to find out the inside reports and visual graphs, whether my data is working properly and whether it can be fitted to the system or not. So this is the experimental setup. Before designing the experiment, what we have to do is that we need to split the data into training part, and then we need to data into the testing part. So this is my available data. But in the new available data, we have to do it into 3 parts. The new available data will be divided into training part and the validation part. So validation will help out to validate whether our results are proper or not. And this is our testing part. So these 3 parts we will be dividing our data, and then we will be putting it for the experiment. Then after that, there are various evaluation metrics, how we are going to evaluate the data. Either we can calculate the accuracy or F measure, sensitivity, or we can evaluate it through the area under curve of receiver operating characteristics curve, Matthew correlation coefficient. So these are different types of evaluation metrics that can be used to evaluation. Now, these are the experimental setup. Then what kind of model that we'll be choosing for doing the experiment? So choosing the right kind of deep learning model is very important part before designing any experiment or any system that we want to get the result. So it's a fully connected network or numerical data. Suppose it is, as we know, this is a ANN type network. So we use it if our data is a numerical data. If our data is text, then better we use recurrent neural network. If it is an image data we are going to work with, then it is always better we go for convolution neural network. So it will depend upon what kind of data we are handling, whether numerical data, text data, image data. Based on that, we will choose what kind of appropriate model we are going to handle. So after the experimental setup, visualization tools are required for reporting. So as we know, without reporting the proper, our successful research work is incomplete if you don't report the results properly. So proper reporting of the results make your paper more understandable. So some visualization tools that can be used are Matplotlib, Seaborn, Inkscape. So there are many more visualization tools are there through which we can report our results properly, that what results we are giving. So this was an overview. So this was an overview that how we are going to set up the experiment and result setting and other can be done. So as a researcher, what will be our contribution to the society as a whole or to the research aspect as a whole? So what we can do, we can build, these are the different aspects that we can do. We can build the medical decision support system where we can help the medical practitioners in diagnosing the different kinds of diseases. We can also help the medical practitioners as per their need to identify maybe the cancer, the exact location of the disease. By talking to a particular doctor, he will help us to find it out. Many diseases can be dealt with our technical assistance, where technical assistance is required. If we go to the healthcare field, if we talk to a doctor, we'll find out that many technical assistance they require, and they require our interventions, and we need to have a proper collaboration with them to have a very fruitful research. So, like cancer, diabetes, like Parkinson disease, pneumonia, so many diseases are there where technical assistance we can put on, and we can help the doctors to easily diagnose the disease and as well as help the patients also. Building local database can help build locality specific models. So we can also help by making small local data sets. So that local data sets, how we can talk to the local hospitals, doctors and the research centers, and then we can have a proper official collaboration with the local medical institutes to get the data officially and their guidance. And that data can be, as I've told you, it's a very big process of making the data set by scanning, cleaning, reproducing and everything. We can prepare the data sets and we can put it online for use of everyone. Many people can use that data. We can also use in our research. Then we can also help in building real-time health monitoring system. We can real-time health monitoring system can also be made. So it will enable the healthcare professionals to track the health of a patient in the real time. Suppose accidental cases like coma cases, as today Nilushina sir will handle with brain analysis case. So in that also, this health monitoring system will help to find out in the real time how to monitor the health of the people, to alert the health emergency in real time. If there is some health emergency situation in the real time, it will alert the doctors or the professionals who are there, so that people can come attentively for that patient. As I told you that we can also help as a researcher by building the health monitoring app for the end users. We can easily make health monitoring app maybe for diabetes, for pressure, for thyroid. So many common diseases are there people are nowadays handling through. So this is a case study I have taken. So machine learning for cancer diagnosis. So actually I'm working for machine learning for cancer diagnosis. I have collaborated with the local cancer hospital of our Silchar. So Dr. Ravi Kannan, we have collaborated with him officially He is the Padma Shri owner of. He was given this year Padma Shri for his greatest contribution for cancer in our locality and the society. So we have talked with him, and we are trying to find out what are his needs and what data he can provide us. But due to this COVID crisis situation, nowadays little bit collaborative work has been stopped now, because we cannot go there because of the infections and the other things. But we are still working on it, and we are trying to find out that whether we can do some contribution to that local hospital through our expertise or through our research collaboration. So here, for machine learning for cancer diagnosis, here first we have started with the breast cancer detection, for which the data is easily available here, and we have done trying to do the prediction for that. And as I've told you, usually first we will do with whatever the data that is available in the online websites and from the archives. And after our model is validated, then we will collect the local data from the local Kachar Cancer Hospital, and then we will validate those data, and then we will apply it into whatever model that we have already made. So apart from my work, here we can put an emphasis on the machine learning can be used for cancer diagnosis. You can see that here it is used for diagnosing lung cancer from chest X-ray images. So you can see this is the chest X-ray images. So X-ray images play a very big role in finding out whether the person is having lung cancer or you can see here the different types of cancer that we can easily find out. This is lung tumor. This is pneumonia, example of pneumonia. So this is using deep learning based ideas. We have a different deep learning based ideas which help us to do this. So this is another case study for machine learning for COVID-19 detection. That is our own paper. Two of my students, Arnav Mishra and Sujit Kumar Das, both have worked very hard to find out this in this crisis situation. They have worked on this machine learning for COVID-19 detection. So here what we are doing is that we are identifying COVID-19 on CT scan images using the convolution neural network ensemble approaches. So here we have used this data source. So this is our example of a COVID-19 situation. So here, as we have discussed this deep neural network technique, VGG16, Inception V3, ResNet 50, DesNet 121, DesNet 201, these are the different kinds of deep learning techniques that we have applied on the images. And then after that, we have find out the individual decision for each of the deep learning techniques. First one is giving negative, second is giving positive, since he is having COVID-19, third is giving positive, then fourth is again giving negative, fifth is giving positive. So now we are doing here, the technique we are doing here is the decision fusion. So here you can see, here we have used 5 different kinds of deep learning techniques. Then the result we have fused together with the majority cases. So here the majority is 3 positive and 2 negatives. So that means after the decision fusion, we have find out that since majority voting is positive, the person is suffering from COVID-19. So why they are doing all these things? So that since it is a very sensitive application, since it is a life and death, because people are very scared if they are having COVID-19 or not. So if we design a system using one deep learning neural network, so maybe it may not give us the proper result. As you have seen, VG19 is giving us negative. Again, Inception V3 is giving us positive. So that's why we have tried with 5 different deep learning neural networks and then seen what is their result, and then we have made the decision fusion of the majority voting. Since it is a sensitive application, so that's why we have used more and more deep learning techniques to verify whether the person is actually having COVID-19 or not. To my pleasure, that this paper is already been published and accepted in an SCI based journal, which I have listed it at the end. And this is a case study for automatic diabetes prediction. Actually, we are working on automatic diabetes prediction. One of my students, Sujit Kumar Das, he is working on automatic diabetes prediction. He is doing very good work. So we are working here on the PIMA Indian database. This work is also published. So here we are taking the raw data. We are first cleaning and data cleaning and data pre-processing. As I told you, it's a part of the data work. So after cleaning and pre-processing, then we are training the data and then testing, and then we are training the ensemble learners. Finally, we are training test on the test set, and finally we are finding out the best model. So pre-processing, now what helps is that it helps in the null value handling and outliner detection. And here oversampling, SMT and addition we are using. So here we are getting 80, the accuracy we are getting more than 90%. This is another case of diabetes, which is known as diabetic foot ulcer. Here this is the normal image of the foot. So once a person is suffering from diabetes, there is a foot ulcer kind of thing which he suffers at the below level of the foot. So it looks like a normal crack. Actually, it's not a normal crack. It's due to diabetes. He's suffering from it, and this can be find out, as we can evaluate this kind of abnormalities only from the images of the foot. So these are the abnormal images. These are the normal images. So from that input data, we are trying to find out that whether the person is having diabetic foot ulcer or not from the images of the foot. So here the input data is given, and then traditional convolution is given, and here the parallel convolution operations are applied, and finally we get the fully connected network, and here we are finally classifying that whether the person is having the diabetic foot ulcer problem or not. So in this case, we can see this convolution neural network, as I told you earlier also, that if you want to use image as data set, then during that time, the convolution neural network plays a very good role. So here is an example that we are using the convolution neural network. So this comes to my end of my today's talk. Maybe the time is also up. So these are some of our recent publications that we have already published. So there's identifying of COVID-19 from chest CT images, a deep convolution neural network approach. So it has been already published in Journal of Healthcare Engineering recently. It's an SCI-based journal. And another paper we have on deep learning techniques dealing with diabetes mellitus. It will be published in Healthcare 2020, a book chapter. Then we have binary particle swarm optimization based feature selection for improving breast cancer prediction. These are all healthcare publications that we have. It was published in a conference in Delhi, and we got the best paper award for this paper. And genetic algorithm based selection of appropriate biomarkers for improved breast cancer prediction. This we have presented in London, United Kingdom, in SAI Intelligence System Conference. This is one of the top 10 conference of the world, and we get a lot of appreciation for the work that we are carrying out. And this is another work by Sujit and Arnav and myself, automatic diabetes prediction using tree-based ensemble learners that I have told earlier. So it is actually listed in UGC. So to conclude my presentation today with, there are many real-life problems that we can solve using this machine learning. Just we have to think only that what contribution we can do. We have to, and there we can apply easily the machine learning. ML and real approaches, they have showed a very great promise in several domains. It not necessarily to healthcare, it can be applied anywhere, as I have given you so many examples at the beginning. And the research problems need to be identified and defined properly. So that is the very big thing, that we need to identify which research problem we need to identify and we need to define it. Then there are important application areas of ML and DL approaches. We have so many application areas of DL approaches, like as I've talked particularly about healthcare. So we need to identify it and we need to try to contribute into it. Then a collaborative multidisciplinary research is needed for utilizing recent advances in various applications. So always it is better that we should do a collaborative research, maybe with hospitals or any other organization through which we can contribute more to that organization, and we can utilize our research expertise and contribute and help them in that way. So these are the references that I have used for my talk. And for any questions?
Um, Thank you, ma'am.
Thank you.
Thank you very much, madam, for sharing your deep knowledge about research challenges and applications of machine learning, and special emphasis on deep learning with us. Madam, our session was full of enthusiasm and valuable knowledge, and we have received feedback. It was a nice presentation, good presentation, interactive presentation from the chat box. Now, ma'am, we have a couple of questions. Can you, ma'am, stop your presentation so that I can
stop sharing? Okay.
And a few of the questions have already answered by the Arnav chose it. So just I want to present.
Okay, okay.
Ma'am, is it visible? Questions are visible?
Yeah, no, I can't see the questions. Oh, okay. Yes.
Is it, madam?
Yes.
Okay. I have 4 slides of questions.
Okay. So I will take the first question. How to decide whether ML algorithm is beneficial in some area or not? Okay, Mr. Sumit, I would like to tell you is that when you will take the problem, actually, in computer science, whenever we talk about any other area, the ML algorithm comes into picture. Yes, if you talk about neural network, computer network, and other things, suppose you want to work with the networking field, then I don't think so the ML will come into picture. But if we talk about any area where like as I've given you example, if it's a financial application, if it's an e-commerce application, if it's an any kind of applications that I have given you example at the beginning, there you can easily use the ML algorithm. I hope I have answered your question. Next is Uttam Kumar. Can machine learning algorithms be used in stethoscope images? Yes, you can use machine learning algorithms very specifically in stethoscope images. As I told you that you can, if you have a huge data of images, then you can use the deep learning convolution neural network. If you have a small set of images, you can go for any other simple machine learning algorithm using image. You can go to the image part, feature extraction, and all those things. Prachi has asked how to use ML for anomalies detection. Yes, anomaly detection, it can be many parts. If I will give you a specific example of suppose an ATM fraud. Suppose an ATM or maybe credit card you are using in your email, in your system, and you are using your credit card, and your numbers, your details, everything is fed into the office where from you are using the credit card. So if suppose a person who is trying to input the password again and again, the wrong password for the credit card, suppose 5 times, 6 times, 10 times, he is trying to put the password, then there is a the anomaly detection algorithm. There it will be a system will be made there that if the password is hit 5 times or 6 times, the thing will be given that 5 to 6 times it is hit, then you block the card, or you ask the user that whether he is using the system or not. So these type of things are given in the anomaly detection algorithm that you can easily make for any credit card application, ATM application, or maybe emails. You can easily do it by changes in the algorithm. You have to think a little bit onto it based on the type of attacks that we are handling. Then Mr. Sundar has asked one question. In machine learning, can we incorporate lab view programming? I am not aware of lab view programming, so please go through the literature of it. I'm very sorry about it. Arshi has asked, how do you handle missing or corrupted data in a data set? Yes, this is a very important part of handling missing or corrupted data. Suppose we have a lot of data which we cannot handle, or whenever we take any raw data into the system. If I give you any example of healthcare data, suppose you are taking cancer data for feeding into the system. So usually what happens is that many parts, the features, suppose you require 10 features for recognizing whether the person is having cancer or not, his age, his history, his so many features are there. So maybe for 50 people that we are giving as input, the 10 features are not available. Maybe only 8 features are available. 2 features are not there. And for another 40 people, all 10 features are available. So then what happens? For 50 people, 8 features, for 40 people, 10 features. Then what we have to do? We have to cut down the 2 extra features that are available, and then we have to generalize into the 8 features, and then we have to work on it. Okay, so this is how we are handling the missing data. For corrupted data, sometimes we have to remove the data. We have to classify, we have to find out the corrupted data, and then we have to remove it. So it's a very hard, painstaking task of finding out the corrupted data. It takes a huge amount of time to make the data workable. So it's not a very easy task. You have to enter into the Excel, you have to properly work on the data. So it's a very huge task. Sukanta has asked one question. Ma'am, can you explain how do I know if the problem is solvable through machine learning? So I think I have answered. That was the first question of Sumit. Jitendra has asked, ma'am, please describe us briefly that how statistics role is important in machine learning. Is it compulsory to use statistic approach in machine learning? Okay, Jitendra, you see that in the machine learning, whatever the approach we use, either it is NN, either it is SVM, or it is deep learning, these are all statistical approaches. Inside all the techniques, the statistics is going on. So you cannot avoid, these are all statistics. Inside techniques are all statistics going on. So it is obvious that whatever approach you use, these are all statistical only. Yes, you can use decision-based approach that are not statistics, but these are usually not so helpful for bigger cases. Maybe small cases it can help you, decision tree learning and all those things, but it's not so helpful. If you go for a bigger case, then you have to go through the statistical approach. Abhishek has asked, in natural language processing with MI, some sentences spoken in different language. So how to overcome the problem? Okay, NLP I am not acquainted because I don't work in NLP, but I can give you an example of speech processing. I work with speech. So suppose a sentence is spoken in a different language, apart from whatever language it is there, then what we can do is that it can be easily find out in the speech, because the way it is spoken and the database that is already given through speech, we can easily find out. But NLP, I'm not sure because I don't work with NLP. It's a totally different area. Gopal has asked, what is the role of big data in deep learning? Yes, big data plays a very big role in deep learning, because big data, it is usually it's a huge data, as the name implies. In the cloud, we have huge data we have to handle. So that huge data handling we can easily do using the deep learning. Yes, Neeraj has asked, can we use that technology in agriculture? Yes, definitely you can use it in agriculture. It's having a lot of prospects. You can easily explore and easily use it. Bhimraj, madam, can you please explain what are the attributes we can take for iris recognition in biometrics using ML? What is the thumb rule to select important attributes from the number of attributes? This is a very good question. Yes, whenever you select any problem, maybe iris recognition, anything, that is the very important thing you have to find out, that what are the important attributes that you will take. So there is no thumb rule. You have to find out that which factors play a very big role in finding out the attributes. Suppose if I take an image, Suppose I take an image recognition, suppose my facial recognition. So what will play the important role? The structure of my face, my nose, eye size, the lip size, the hair of the color of the hair. So if you see like this, we are having 8-9 features. So based on the problem, you have to decide what are the important attributes that you will take. There is no other thumb rule, I will say. RS Raja has asked, what was the x-axis and y-axis values in that learning of car graph? Okay, so that I exactly don't remember x-axis value. So actually, what car, uh, the car learns on the basis of the human drivers. Usually, when the driverless car is launched into the market, before that a human driver will drive. It will put all the attributes that in the accidental case, what it has to do. If the 3 cars come into the picture, what it has to do. All the inputs are given into it, and then it is set it out into the market, and then the graph calculates that if a human driver drives and if a driverless car drives, what is the difference in the graph, like how much accuracy with the driverless car is driving compared to the human drivers. So that is compared in that graph. So it will not be exact, little bit difference is always there. Sukanta has asked, ma'am, can you please explain how to design the filters in case of convolution neural networks? So it's a very big question. So it will take a lot of time if we put into it. Maybe you can just put me a mail or something. I will try to explain you or give you some materials related to it. Govind has asked, please explain, is it can be used in adult man to reduce the disturbance in power system, and how? So I am not a power system expert. Maybe it's an electrical question. So, but it can be used. Since it's a machine learning, it can be used. That I can definitely assure you. But you have to go through the literature, how you can actually use it. Sagar has asked, ma'am, can you suggest few of the research challenges in relevance to uses of convolution neural network and data science? Challenges. Okay. For this, I will specifically request you please send me mail. I will give you the materials. Okay. Victor, how can a researcher know how can a researcher know if he or she has successfully identified all the research gaps existing in a literature? Can you suggest some approaches to follow? Yes, Victor, you see, as a researcher, we cannot address all the problems, because if we try to address all the problems, it is not at all possible. So what we can do is that take some papers, identify 1 or 2 particular research problems that you want to identify. If you are a PhD student, then maybe 3-4 specific problem you take. Inside the specific problem, you can find out that 3-4 problems I am going to address, and for that 4 problem, you use all your expertise, all your research issues, everything you do, and try to solve that problem. But as in this, you don't try to solve all the problems or all the research gaps. It is not at all possible. So you take one particular problem, and inside that you categorize into 3-4 parts, and you try to solve the problem properly. Okay, Mr. Gopul has asked, can you suggest some research topics in machine learning? I think I have discussed it in my slides. A lot of topics I have given, so you can refer to that. Ankit, whether to use MATLAB or Python or OpenCV, how we can use in astronomical data analysis? Okay, astronomical data, different field, you have to study how you are going to do the data analysis. But yes, as a software tool, you can use easily MATLAB, because in the MATLAB we can use high-end data processing. We can use Python. OpenCV, I don't think so, but Python and MATLAB you can easily use. Mr. Vatane has asked, can we apply ML in cybersecurity to prevent malicious practice? Yes, definitely you can use, but you have to identify where you have to use. Nupur, can we apply ML in fraud detection analysis in various plans? Yes, definitely. I have talked in my talk also. that we can easily use it. Yes, Rupesh, can you explain what is KF score to evaluate performance of the classifier? I don't think so I have discussed about it. I'm not sure what you're talking about this. Pratik, can we do image processing on 300? Yes, we can do on 360-degree camera. Actually, it is not image; it is actually video processing. It takes the real-time audio. It takes the real-time video from the camera and it keeps on processing. So 360-degree processing, it is mainly used in your driverless car. We can do it. So, Frederick, what is induced machine learning? If you require, I will give you some material because the talk is extending a lot. Prakash, how to use deep convolution network for speech data? Speech data, actually the problem is that lot many data is not available. Speech data, the data is very limited that is available to work with. So normal machine learning algorithms, we can apply. So deep convolution neural network does not come into picture usually when we work with speech data. But if you have the huge amount of data for speech, then you can easily use deep convolution neural network for speech. Can you explain how only neural network gives the best accuracy when compared to other algorithms, ML algorithms? Actually, Devjit, it depends upon the application that you are using. In some application, the neural network works very, very bad, and other ML algorithms work very nicely. But in some applications, again, the neural network gives you very good accuracy. So it will depend upon what kind of data or what kind of application you are actually working on. Suppose if you take speech, the neural network works very bad on speech data. Maybe in any other it works very good. Dr. R. Das, Mr. R. Das has asked, CNN be used for RNA sequence analysis, since we know CNN is best suited for image. Yes, any image application you can use convolution neural network. You can easily use in RNA sequence analysis. Any image, it may be anything. Shailaja has asked, which is the best GL algorithm for emotion recognition? You see, Shailaja, it will depend upon the data that is available to you, as I've already told you. So if you have lot of data, that only you can use emotion recognition. Since emotion recognition is related to speech, so as I told you, lot many data is not usually available. So if you have huge amount of data, then only you can apply DL. And if you apply DL, then avoid those CNN and all, because CNN you cannot apply because it's not an image, it's a number data. So based on that, you have to think that which DL algorithm will be best. And the best way to find out which DL algorithm is best is that you experiment with all the DL algorithms and see which algorithm will give you the best accuracy, and then you compare, and then you can easily publish papers also if you have experimented with 5-6 DL algorithms. And Usha has asked, ma'am, what could be the ideal size of data set for experiments? There is no ideal size, Usha, because it will depend upon what data you are using. Whatever data, ideal set of dividing the data set is that 70% for training, 30% for testing, or 80% for training, 20% for testing. Data set may be anything. It will depend upon what kind of data you are having. There is no ideal size. You can, if it is huge, you use deep learning. If it is small, you use machine learning. Last question is, Swapnanil, is there any source where I can get information about all the DL algorithm discussed today? Please help, kindly share the slides. Obviously, I will share with the slide. You can either contact me directly through my email ID, or you can talk to organizers. Link also I will share. You can contact with me personally through email. Thank you.
Thank you so much, ma'am. I want to thank you once again for your informative, interactive session, ma'am.
Thank you, Malaya. Thank you.
Thank you
I'm
so
very
much.
happy people have responded so well. I will share with you the slides and materials. If they want, you please share with them.
Yes, definitely, ma'am. Thank you so much, ma'am. Thank you so much.
Thank you.
Participants, let's have a break for 5 minutes and then we'll join after 5 minutes. Thank you.
Thank you.
Sir, good morning, sir.
Sir,
Good morning. Hello. Okay, go on.
Welcome back to the second session of Day 2 MLCV 2020. Now, let us have the pleasure of listening to the Honorable and great speaker, Professor Nidal Sinha sir. Professor Nidal Sinha sir is working as professor in the Department of Electrical Engineering of NIT Silchar. His research interests includes power system optimization, automatic generation control under conventional and deregulated environment, application of soft computing techniques, technical forecasting, case-based reasoning, and intelligent instrumentation. His research has been published in FCA journals and conferences of repute. According to the Google Scholar, till date, he has 4,173 citations for his research. Sir has been invited to deliver lectures in several institutions of India and abroad. Now, may I request you, sir, to kindly deliver your speech.
Okay, thank you. Good morning. Yeah. No, is the slide visible? No, just yeah, yeah. I opened it. Just for that. Yeah, yes. Wait. But it is coming something. Your window and this window is coming. Something. Where is it? What is that? No, it is some problem. No, this window is coming. Only Google Meet, this window is coming. When I am asking for the whole this one, I don't know what is that. Wait. Yes. But PPTs are open when I am trying for that. What is that?
Sir, you can use second option, present now a window. Then you can click on that and share, sir.
No, present now. It is okay. A window is there. First is your entire screen.
The second one,
it is not coming.
sorry,
Second one is a window. That also it is
yes.
coming. No, it is by default. It is going to that. Okay, there is. Here it is coming. Here I have seen that one because it was coming in earlier. It was coming only the Google Meet window was coming.
Okay, sir.
Now it is there.
Sir, yes, sir.
Right.
Now you can make it, sir, full screen, sir. So you can press F5.
Yes, I'm pressing. I am pressing.
Okay, sir.
Here I have to press more. No, it is F5 also is pressing. No, it's not coming. Wait, wait. No. You just make it. Okay. F5. Okay, I'll just. Okay, it has come.
Yes, sir.
Okay.
Yes, sir. Yes, sir. Sir.
Okay. So. But I don't see the other part like that. It's just on the whole screen is coming. What do you mean? Okay. Okay. Good morning. Anyway, this has been that that the human brain happens to be my passionate subject, and specifically, I don't think that I am an expert in this domain. I am just learning, and so today's lecture I'll try to share whatever things I have learned or we have realized in our group. At the same time, means what through discussions with other experts in this domain. And there are some other issues which I not addressed to all today's lecture. There is another lecture tomorrow, and some part of that will be I'll be going for that one. Some will be similar, some will be little bit of in the different directions. But the brain happens to be my passionate subject. So because of that, have been associated with this one. It is recently maybe around quite you know 6 to 7 years back we started working on that. So right now 4 research scholars are working, and one will be submitting in weeks time. Today, what I'll do is I'll talk about some of the issues there. Some of the issues related to the brain signals, the importance of uh, different type of brain signals there. Maybe all may not be able to be covered there. Then, of course, today's, of course, from application part point of view, EEG part, I'll be covering for that. Tomorrow, today's part will be application specifically on the silent speech reading, or people may get confused with. Okay, but not only that, fascinated with the idea of silent speech. Somebody thinks somebody is thinking in the brain. It is ideas. It is not ideas. Of course, we wanted to have that one in the direction of that reading that hidden ideas which are coming up in the brains, human brains. Anyway, but ultimately we settle down with the silent speech only, and I'll talk about that also. I'll just share some of the results we have achieved there. But again, my resentment or my that still that the feelings which means my my zeal or that passion for knowing more and more in deeper way. This is not happening. I'll share that part also. In terms of the machine learning techniques, I'll see of that what are the limitations, what are the things we did, and what are the things which we could have done it, or probably in future we'll be doing, because that 4 research scholars out of the 3 are working in the different directions. Almost that's higher perspective of that. So that followed by of course that we'll start up with that, of course, with the first as the video is there, which will give some glimpses of that what is happening in that brain research or brain research into that one. But the application is numerous. Application means there is no end to that, and it is very difficult for one or few persons to address to all there. Only in a team or something like this, a group of from the different field and different expertise, only that is possible to come up with that. So I don't know how much of that. I'll just think for that. So before I start that one, I'd like to just play a video there, and which you saw that means what some of that what is happening in the brain research. That some of that one. Probably I don't know whether I'll see that is the first time I am doing. And if it is, because I wanted to, because I have a plan to stop it there when that something is going on there. What are that research domain or what are the challenging areas there? That if I can address to that in the movie only, then it would have been there. Anyway, I'll just see that. Okay.
Have you been here before? If this house was a crime scene and you were a suspect, you'd say no. But what if scientists could look inside your brain and work out that you've been to this house after all? Don't worry, they can't. Yet. But this is one possible future use of a technique called brain decoding. We'll be coming back to these rooms later. Neuroscientists often use brain scanning techniques like functional magnetic resonance imaging to see which areas of the brain are active during tasks. Brain decoding looks inside these active areas to identify more subtle patterns related to particular images or ideas. A typical study would put someone in a scanner and show them a series of pictures. For each picture, the scanner records activity in the areas of the brain responsible for vision. A computer program, the decoder, is then trained to associate each picture with its pattern. To test the decoder, a new picture is presented. The scanner records the activity again. The decoder then compares the new pattern to the pattern it knows from training to figure out what type of object the person was looking at.
My name is Jack Gallant. I'm a professor of psychology and neuroscience here at UC Berkeley, and my lab works on vision. That's our main focus is on the visual system. And vision is a really important thing to work on because humans are very visual. And when humans have damage, you're not.
Oh, it is not. People are not seeing. Oh, you just click on that. This one. Because without that, I cannot ignite the mind. That has to be. The video. You close the video and then. Okay. Oh, okay. But you go to that, then you can go to the first part of the video. Yes, yes, yes. Is it coming?
Have you been here before? If this house was a crime scene and you were a suspect, you'd say no. But what if scientists could look inside your brain and work out that you've been to this house after all? Don't worry, they can't. Yet. But this is one possible future use of a technique called brain decoding. We'll be coming back to these rooms later. Neuroscientists often use brain scanning techniques like functional magnetic resonance imaging to see which areas of the brain are active during tasks. Brain decoding looks inside these active areas to identify more subtle patterns related to particular images or ideas. A typical study would put someone in a scanner and show them a series of pictures. For each picture, the scanner records activity in the areas of the brain responsible for vision. A computer program, the decoder, is then trained to associate each picture with its pattern. To test the decoder, a new picture is presented. The scanner records the activity again. The decoder then compares the new pattern to the pattern it knows from training to figure out what type of object the person was looking at.
My name is Jack Gallant. I'm a professor of psychology and neuroscience here at UC Berkeley, and my lab works on vision. That's our main focus is on the visual system. And vision is a really important thing to work on because humans are very visual animals. And when humans have damage to their visual system, they're really incapacitated. And that's what was the goal like watching a movie. So essentially, we were trying to build a model that describes how your brain responds. So the external world is a certain kind of movie. We want to be able to build a dictionary that will allow us to accurately predict what the brain activity would be that would be evoked by that movie. And then given some brain activity, we want to be able to reconstruct the movie that we saw. So on the left here, we have a movie that we saw. And on the right, we have a brain. And you can see the brain activity is painted here on the side of the brain. But the brain's kind of crunched up to the skull, so it's hard to visualize. So we kind of inflate it, and then we flatten it out. We can see it flatten out to the cortex and the rest of the brain as opposed to watching some movie. The problem here for us is to translate between these movies that occur and this pattern of brain activity. And in the study we talked about in a paper, we just modeled this very back part of the brain, the early visual system, primary visual cortex. And that part of the brain responds to little local features in the movie, little edges and colors and pieces of motion and texture. But this part of the brain doesn't know anything about what the objects are in the movie.
Researchers have just demonstrated for the first time that it is possible to turn a person's thoughts into a legible phrase using what they are calling a brain-to-text interface. The continuously spoken speech can be decoded into the express words from the intracranial electrocortical pathway of recordings. This involves using needles to record signals directly from your person's neurons. It is an invasive procedure, requires an incision to the skull. This brain-to-text interface was tested with many volunteers. As subjects read pre-selected text aloud, implanted electrodes recorded brain activity to an epoch bit. Machine learning algorithms were then used to extract the most likely word sequence from the signals, and the automatic speech-to-text method created the text output. Error rates were as low as 25% during the study, which means the potential for the system is pretty vast.
To which this nation has always been committed and to which we are committed today.
The findings could offer locked-in and remote patients a valuable communication method, but it also means humans could one day communicate directly with a computer without needing any intermediary equipment. However, brain-to-text seems unlikely to make it into a consumer product unless the researchers can develop a way to access brainwaves without cutting the head open and exposing the brain.
Okay, thank you. So I think it is really observed there or not. This is what. So the first scene was the use of fMRI. fMRI is slightly different than MRI because it's a function-based MRI. Specifically, it is used for it is used for identifying the regions which are getting activated when some functions are done by committed by the subjects. So that is what you might have seen that. It is a simple example of showing the different images of cat, houses, and others like that. Then what was the response of the fMRI in the brain in the form of fMRI image? It was taken for that. It is very simple to say, but the thing is, I don't know that you have followed that one or not. When it is gone to that, UC Berkeley, that these people they have tried to decode that images of the movies and other things from the fMRI map. image map. It is basically the image map, and this is basically two-dimensional. So we have this spatial type of informations there from the brain we get for that. So and of course, I have not gone for some of the videos. It is already available in the net. It's a YouTube videos are available there. And but the thing is, what recovering that from the fMRI images, recovering that what are the scenes and informations which were experienced by the human brain, it is very limited. The success rate is very limited, because there are a lot of challenges for that. Because only with the two-dimensional, that I think whoever are associated with the working with the image processing and other thing is there. With the two-dimensional, with the variations of the different features, and features also anyway, that features also what that as I'll share during my subsequent part of the lecture, that it is some way of some sort of frustration that the way we apply, or most of the people researchers are doing like that is there should be some sort of innovation in the way of addressing to the whole that events, and then human brain, and then events are there, or brain events inside the human brain. It is not outside that one is there. So what is happening inside, and what we want to do is that what we are doing, what we are getting, and how are we using that one, exploiting that information in using that exploiting the machine learning technique, or maybe the intelligent techniques are there. So from every perspective, there is a that gap is there, communication or interface gap. That is what today probably I'd like to share for that, because in 1 day or 1 hour lecture, nobody can be made expert or something like that. I feel that if I can share my concerns or my feelings at this time, probably that will be okay. I'll feel that if I can motivate some of you, then I feel that, because it is a huge task, and it is a multi-dimensional, and then multi-directions, and numerous implications are there. Means what in terms of the positive developments, because somewhere people have to start for that. We have to the society has to go for or I can say the scientific society has to go a long way for that. And whereas there are areas, or there are prospects which always limits to go in the direction specifically from Indian context. I'll share that also. That part is there, because I had a project there, what happened and all these things. So this is what graph for that electroencephalography, that one is there. What are that? Its prospects are there. Then what are its constraints are there? That is what that this has got. When we go for that EEGs, something like what happens here, the time resolution is higher, and whereas in case of fMRI, that resolution is very poor in terms of seconds. Just you can see that one. So fMRI gives us spatial information, it's not the time domain information is there. So temporal information is not much information is obtained. It is one can project it in different directions. That is a different part. Like converting into that is the variations of the frequencies, and based on the color patterns and others, like there is that in terms of time. That is indirect ones. Okay, but anyway. So and EEGs are very portable and affordable. So that this is portable, affordable, and is very convenient in the sense means that we don't have to cut open that head to place that EEGs are there. They're just simply placed on the skull. So it is very even subject also is very feel comfortable, and then it is not also risky for that one is there. And EEG is silent, and so useful for studying auditory processing there. And anyway, that is another direction one can go for. That can be combined with fMRI and TMS. This is what is missing in Indian context. I have seen that. I have talked with some foreign neurologists there. Indian neurologists I talked, but there were some limitations. I'll just share that also. That we were associated with. I was associated with some professors, they neurologists, the foreign professors there. And there I have observed that they do have that the practice of taking regular EEG, fMRI, TMS data from the patients there, and they really go for more scientific way and very methodical, very systematic, consistent, so that ultimately they come out with very useful and what that very useful product for the society there. Not from the Indian context. Somehow you get a journal paper and get points and get promotions and all this thing. I'm fed up. Really, in personally nowadays, I feel very much frustrated because of so many years of one association with the the Indian research. And nowadays, I feel frustrated because of this. The contributions toward the society. Forget about that. I had been there in IIT also. I know also that means big shots and IIT professors there. I attended their classes and I've seen their achievements in terms of that the patentable means basically societal contribution other than producing MTech and PhD and number of paper publications. The societal contribution is very limited. So-called that means direct impact to the society there, and that makes very much frustrating for me there nowadays. Anyway, so okay, before I go for that is there, I think I should say about that. One fact is there. Whether we use, ephemera, we use EEG, we use MEG, we use TMS, all these devices are what? They are basically what? Trying to capture that the activities which are occurring inside the human brain. What do you understand by that? So basically, we know that I don't know that I have taken up that human brain. Human brain, what specifically that we in human brain we have basically three parts there. Okay, that's the main brain there. We call that one is the cerebrum is there, then the midbrain is there, and then cerebellum part is there. Cerebellum is a mode of basically controlling of that body and then the muscle coordinations and other stuff, not the intelligence and other parts there. And whereas the cerebrum is that responsible, what is that we call that by brain, so-called it is there, and it has a very much coordination with the midbrain there. Midbrain is what I don't know that is there. I'll see that. Okay, midbrain part is there or not? Okay, these are the different. Oh, okay, it is not given. Anyway, so I feel that. Okay, so that means what that the target or the objective of all the devices here, any device, even tomorrow some more devices may be coming up with it, because of the development of nano sensor or maybe pico technologies, reality is coming up for that. So in that case, what happens is the objective of all the scientists are what that the how that for a given event, event maybe in terms of what doing some actions or in terms of what thinking something, like you just generate a new idea. This is an innovative idea or something like that. So anyway, that where does it come from? It has to come from the brain. Where from the brain? Suppose I said that innovative idea has to come up from there. What? How could we understand that it is innovative idea? Why you call that innovative? Because this is something which is odd in the sense means what? This is very new, which is never heard before. Okay. Anyway, but that is generated within the brain. Anyway, that any thought process, anything happening in the brain is in the form of what? The billions of neurons which are getting excited, at the different parts of the brain, in different regions are there. And then in the same region also that the different number of neurons are activated for that. And all these issues means what? What are the neurons which are activated? Okay, in different, the activation may be what? That also it means the responses. Activation means the responses will be there of the neurons there. So we try to capture that one. We understand that the billions of neurons we have to carry. Can we capture all billions of signals from the billions of neurons? It is never possible like this. So what is happening in this case is what? That either region wise, because every region will have maybe there will be thousands or even the millions of neurons will be there in a particular regions will be there. So that a region get excited means what? That excitation is what when we want to capture that one, the region is excited or not. It is basically what? That it is the collective, cumulative, that development of that across that all the millions of neurons in that particular regions there. And for different event, different activities, the same region responses will be different. That is what we want to capture. So anyway, so now the thing is how these devices they act for that is basically any neuron. When nerve cell, neuron is basically the nerve cell there. When neuron wants to get excited means what it has to get, first thing is what it has to get energy. for excitation of anything, every event, forget about this one there, it requires energy. Where from does this energy come? It comes from what? First thing is the glucose is required for that. We know there is a very ready-made that that glucose is required for that. This is what is the food, and the energy will be produced only when what the glucose is burned. Glucose is burned. The food is burned for that. Carbohydrate is burned. That means what for burning we require oxygen. So ultimately, what all these devices, specifically fMRI or MET and others, they call for that is what that the flow of oxygen. What do you mean by the flow of oxygen? How does oxygen reach to the different veins, different neurons in the brain? It is through the blood supply. So ultimately, flow of blood. There are TC Doppler machine. We wanted to have that for our project also. We stopped it ultimately. That same machine also, Doppler machine, is due to the Doppler effect. It gives an indication about that. What are the areas where the blood flow? In the neuronal neural way or human brain that is getting more and more, and what level and how much higher. That are the things there. Same is that fMRI also. It is coming up. That one is there. We go for that MRI, that magnetic resonance. That one is the flow of oxygen, and we know that 90% of the blood has got water. So the water also means what has there is an hydrogen, and oxygen flow will be there. Ultimately, that the reflect of that, when this water or blood is made to flow, water is made to flow through that under the magnetic field of what 1 Tesla, 1.5 Tesla, 3 Tesla, 3.5 Tesla, or something like that. Very strong magnetic field then, and at different frequencies, and the responses will be captured for that one. Based on that, the principle is there. I'm not going for that today. Anyway, but that only that the problem with this one is what we get. This one tells about that means where are the different blood flows occurring within the different regions of the human brain. Okay, means oxygen flow is there. We get the information for the fMRI. So the thing is what we know that the which areas are activated. But the thing is, what do you mean by activation? Means what? There will be responses. What do you mean by what do you understand by the responses? Every response will have what? If it is a brain part there, cerebrum part is there. So brain part response means what? It will be in terms of response will have 2 parts, maybe 3 parts. It is a 2-dimensional or even 3-dimensional also. We can even 2-dimensional part. The first thing is what we got the spatial information, so which are the regions which are getting activated for a given task is there. This is one part. Only this you will find number of activities for that one. Similar regions will be activated. Now, how can you distinguish? We have already observed that one. I'll share for some of that. I don't know if time permits because it's already late. Because I have today our classes started for that. I don't know how much we can go for that. I have a class today also. So anyway, so this is what. So so we get what the fMRI gives us the spatial information is there. This is no way means giving us likely to give us what discriminative information which can be useful for classification. You see that intelligence, as I told about in some other lecture, intelligence is what majority of the computer science people, or even that the people means I say the intelligent people, they talk about the intelligence. Intelligence is what that maximum 30 or optimistically 40% task is what? Classification. But the remaining all that parts are what? Remaining whole part. You have the 60 to 70%. That one is for reasoning. That is more important for that. That is more important. Suppose that events or series of events are given. It's a picture type. It's the different events are given. Like same way the way you might have seen that, you might have read that the Sherlock Holmes book there, and just having that whatever the picture in front of you, and this is the sequence of events there, sequence of images there, and with that one you project it, give it to the thousands people there, and how many people will be able to come out with what reasoning which is intelligent enough to pinpoint that this set of images or the events point to what are the inferences. I doubt how many of the 1,000 people will be able to come out with an accurate one, whereas that Sherlock Holmes could come up for that. That means what the success rate comes up for the how intelligent reasoning you incorporate into the system. Classification is basically the beginning of that. You just first thing, classification is nothing but it's a pattern. You have a pattern or information there. all the different information should be classified or categorized under different patterns or different groups. And then you come out with a relationship, correlations among all the patterns, the different interrelationship. If you are capable of that, exploit that one, then come out with a reasoning which is intelligent enough to pinpoint that exactly this series of events point to what inference. So okay, that is what I was talking about. That we have an fMRI there, but the thing fMRI gives the spatial, it doesn't give the temporal information. As I said, you can come up with indirect temporal, but that will not be much useful because the responses of the neurons are in milliseconds there. The flow of the blood flow, and even that one when it happens to be there when the soma or cell body, neuron cell body gets excited, soma gets excited, then ultimately through the axon hillock, it moves towards that. I'm not going for maybe that could have been the like going for a neuron there. Anyway, some part I'll see that one. Okay. So temporal informations we get only from the EEG signal. Temporal information we can go for that. So we place the electrodes on the different regions of the human brain, and ultimately the electrodes gives us that the brain signals in the form of variations in the millivolt or sometimes microvolt, or the variations of the voltage. Because why the variations voltage occurs? Because of that flow of that chemicals, flow of that the impulses in the neuron, from one neuron to the another neuron there is there. So that creates the variations in the potentials across the different cells, and even same cell, different parts of that one. So as I said about that, electrode placed on a one particular point of skull, for the head is there, below that one there will be millions of electrons will be there. So we can never target what are the impulses coming from that few electrons. No, it has to be always a collective one, cumulative effect of the impact of the variations of other potential differences which are being reaching up to the surface level of that electron level is there. Anyway, so there are still, we have observed that there are, we can get that when the brain gets or human bodies, what this is doing some activities there will be oscillations which are created for the in the form of in the neuron. When the neurons get activated, then oscillations are created, and that oscillations are also happening in the form of voltage variations. That is how we exploit that one for getting the informations in the form of what voltage, the EEG. That is what we say about that. The problem with EEG is what that we can go for that means the temporal information, spatial information we can go to some extent, but not resolution is very poor, because we are placing what spatial information depends on the how many electrodes you place on the head, whereas fMRI is what whole region is covered. You can see that in the MRI image part will be the almost every part of the regions of the brain part is covered in that portion of that one, whereas in the EEG, no, it depends on that what electrodes placed at around that one is based on that we come up with that. So in between one electrode to another electrode, one can come up with the extrapolation and interpolation between that one, and that is how one can get that what could have happened in between the two electrodes or in between the electrodes. That is what, but it is limited. I have seen some journal papers working on that directions also. But anyway, that is because something is better than nothing. That is what half a loop is what better than no loop. That is what. Anyway, so but that very advantage is what EEG is very cheap. fMRI is very costly. It runs in crores. Okay. And that is what they are weak of for that. So as I said about that, EEG or even AVG or even fMRI, all are related to the activations of the neurons, and basically activations of the neuron happens because of the which requires that glucose as well as oxygen flow. This is possible only with the help of blood. So ultimately, by seeing these things there, we can say that one is the blood flow is more or disturbed. If it is disturbed, that is what the brain responses will be disturbed there. Anyway, TMS also transcranial magnetic stimulation, that also some people they are using for that. I don't know India how many, because I have not seen it. Most of that your this one nursing homes and others, they are go after money. They are not for research. They are not for coming out with anything contributing to the society other than treating that one. instead with money. So whereas the research in that direction means what, it is very very limited in India. I have seen that for in they are using the professors, they were talking about me with this type of that one they are using for that. Okay, so anyway, that is what this is also only surface structures of the brain we get for that one is there. Okay, basically this is what specifically in the depressions there, that depressions and other type of mental states which are that low energetic states and very very useful for that diagnosing that state of a brain state of a or mental state of a person's there. Okay, anyway, this is what I say is what that is the multimodal imaging, that one, or multimodal you can go for that say analysis there, which is what of recent origin. That one, as I said about that, is not much happening. You do not have that any device which will go for that, even ready-made handy available there, which will be using that one, 2 to 3 to 4 types of devices across that one is there. Because suppose you go for the fMRI gives spatial information, spatial resolution, temporal resolution is very very poor. So you connect with that one with the EEGs, you get the both combination of these two are supposed to give for that. But the thing is, again, there may be some limitations on that. Even fMRI and EEGs are there, and that case means for some, suppose if you want to fine tune that one, then that ECOG is there. Okay, that event related also potentials that also is there. So you can come up with that the different type of that sensing devices and then different type of informations which will make that one as which will help to improvise that the decision making systems there. That is what. Anyway, that is what there is something some I have taken from the net only. You might have seen that one. So what is happening in that one is there. Anyway, okay, this is what I said. That one is there. This is the cerebrum part. This is what we call that the brain means. This one is there. It is different areas will be the which are responsible for doing different activities are there specifically for that. So we have to click on that. As I think whether in the video you might have observed that or not, when the electrodes were placed on this, on the skull, you might have seen that the more electrodes were placed on the Broca's area is there. This is speech area, both are speech area. They wanted to to extract that the signals from there. So more number of electrodes pierce into that human brain, that one, specifically Wernicke's area and the Broca's area. This was the speech part is there. And that based on that only they come up with that, means what they could identify that what are the words which are being spoken by the person or thought in the human brain. That one is there. Anyway, that is one example. So now I'll give an example for that before going into that. Okay, that story about. Okay, this is almost not many times. So 20 minutes left or something like 22 minutes anyway. So okay, what I'll see that one. This is regarding the project there. Okay, our project was based on the reading silent speech, recognition of silent speech using human using brain signals. We say that one. So by brain signal, we wanted to initially have to have not only that EEG signals but also TCD machine was comparatively cheaper. The TC Doppler machine that could have given us spatial information, because temporal information we can get from the EEG. So we wanted to have the both multimodal, whereas fMRI was very costly, very costly. Anyway, that one is there. That when the project was implemented, when it came up, it was sanctioned for that. Of course, all that while presentation of the project in the Delhi, so everybody got excited when they heard about that, something like that is there. But when we started the project there were many that frustrating things happened. That one is there because that committee chairman was from the speech domain. He was from the NLP type speech domain. Who doesn't know ABC of signal processing and other like that? Whereas our whole research was based on that brain signal, EEG signal. It is totally signal processing domain. You have a totally highly randomized signals there. A person who doesn't know much about that one, how we can okay, for formal sake, if somebody want to chair that meeting, that is a different part. He was against that. Our thought process or our objective was what, that we wanted to study that what are the brain signals when somebody thinks some particular idea is thought by the subject. And of course there were challenges for that. there were challenges for that, because when somebody is asked to concentrate on some particular idea, there may be so many more ideas will be crossing his mind. How to separate that? That is where, anyway, that one is there. But these people, they forced me that to go towards the direction of what, that first thing is what they go for. No, don't go for idea, go by words, or not words, go by letters. You see, if you want to go for the English language there, the English language is what they are made of the letters there. And letters, again, you come up with that one, vowels, consonants. Then you have to identify through the brain signals, vowels, consonants, and coming up for all these things there. So I was forced to go in the direction. We did it. We completed the work is there. Only for the vowel part is the vowel of the English and Bengali languages there. We wanted to have the plan for the Hindi also. Anyway, we could not, because time did not permit us for that. So we have gone for that is there for the two languages for that. But the thing is, all the time I was having the frustration and that depression in the mind, because of what the way I wanted to do the research, it was not allowed. So ultimately, after that one, I closed that project there. After that, what, even they forced me to transfer the equipment to the other part there, because they say in that chairman, he was concentrating on that. God, you see that when a sentence is formed, how a sentence is formed. So first thing is you have to identify through the brain signal different type of letters, vowel, consonant. Then with the combination of vowels and consonants, you come out with words. And then with the words, a combination of words. Then combination of words together means you have that what is semantics and all these things will be there. Then after that, what, you come out with a sentence. It was maybe in my whole lifetime, forget about my lifetime, my next generation lifetime, or even next generation lifetime, it might not have been possible, because you have to go for 26 alphabets and other all these things, different alphabets or different combination of that alphabets. There will be thousands of combinations will be there, and then making of the words, then combination of words together with the phrases, and then coming up. This is a horrible case, and I could not make. Anyway, that ultimately the thesis which is being submitted, which is based on the work done by that one, is there. But later, because after that I have procured another one, same EEG machines there. It is more effective and more comfortable for that. It is excellent one, to share with you is what that when you submit a proposal there, even it may be recorded and shared with the ministry also. Even other day I was banging the ministry people like that is there, like that. So I don't care for them, because I have never committed any mistakes or other way like that is there. But the thing is what, anyway, I'm not referring to other issues there. So what I said, that we have gone for 128 EEG machines there. 128 EEG machines. Forget about 128. 64 EEG machines also. If it is a very good machine, high quality machines there, it will not be less than 45 to 50 lakhs. If it is 128, then it will be not less than 78 to 85 lakhs. And when we submitted the proposal for the 49 lakhs, they started bargaining. You know that you go to the subji market and others, you go for that one is a bargaining and all this thing. I mean, I don't know what was the reason. There was no money. Then if it is no money, then don't fund it. So ultimately what they were bargaining, can you manage it within 25 lakhs? Can you manage it with 30 lakhs, 25 lakhs, like that, something like that. So because of that, we dropped also. Even TC Doppler machines and other like this, we concentrated only on the EEG machines. And that also we have procured a Chinese EEG machines. Their 128 channels. It was comparatively cheaper, and that also means what you have to depend for that. Anything you buy for that with the compromising money of that one. The only problem with that machine was that there was no software, analytical software, analysis software, which was inherently available with the machine. They have given only the drivers, so that once it is there, you use the machine and you can connect, you get the signals in the computer. Of course, my requirement was not to come up with that one. Some analysis that could have been useful, but anyway, we have developed our software. That was our objective, so that we could identify that, or we can achieve our objectives. That was there. Anyway, we could do that one is there. Even we have modified the machines also, using that Indian expertise. That company who's applied for that one is there as in. Anyway, so these are the stories of that. Means Indian mindset and doing something good is. I doubt. Anyway. So anyway, this is what I said about that Wernicke's area, or this is what then Broca's area. This is what were the two areas are there. As I said about that, you can see that this is what the Broca's areas there, and this is what we see that the Wernicke's area. These two parts, that one. Anyway, but when we have gone for the signals for the easy that one. Anyway, this is what ECG, that one signals are there. You have to pierce into that, and placing on the brain is there. And this one is what non-invasive is, the EEG part is there. Anyway, that part is there. Okay, this is what, okay, I was talking about that. This is that, that this is soma is there. This is the neuron cell, and you have this is a cell body. Cell body is that way it's called also soma. And then from the soma will have a nucleus will be there, and then you have cell body, then other constituents will be there. And you have here specifically in the cell body, there will be a number of dendrites will be there. Dendrites, that dendrites are very small, like hair type, microscopic. That one is there. That extensions for that. They are the dendrites. Ultimately, that the signals get that arrive to the soma, or the soma cell body gets excitation through the dendrites there. There will be thousands of dendrites for every cell will be there, and so now you understand that every dendrite will be there. It will be terminated with another neuron. So what is that? This part is what this is axon hillock. That is what you see there. Axon hillock is there. This is just joining, but this is action. This is action. So when the cell body is what cell body when excitation. This is what neural network we go for that. Inputs are weighted input. Every input are coming through the dendrites, and then the higher stronger signal means what weight will be more. That is what you get for that. Ultimately, this is you have a soma is represented with a threshold function. Then it gets excited, and then signal will be generated, and it will be coming out from where the axon hillock. Axon hillock is the main part which generates the signal. Means the signal is in the form of what the variations in the potential difference. That sodium ion, positive ion, and potassium and negative ions there. You have both positive sodium ion outside and potassium ion inside. And all this is what you go for that. So initially, when it is not excited, both it is electrically neutral. Means the number of sodium ions outside and number of potassium ion inside, that will be same. So ultimately, potential difference will be same. But once it is excited, then there will be ultimate exchange of the sodium ion and potassium ion. Ultimately, there will be variations in the potentials. That develops into that. There's a waveform. It travels through this action, and it terminates at the terminal here. And every action will be connected or terminated with a dendrite part. That is what we call it the synapse. The junction of an action terminal and with a dendrite is called synapse there. So that ultimately this excited signal reaches to the action end part of the action. That one ultimately what that creates an excited means what that creates a transmit that neurotransmitter. The chemicals is basically what. So ultimately that through the neurotransmitter it reaches to the other part of that the dendrite part there. Again the same signal gets means variations of that the same one, the potential is one. You have that positive and negative ions and like that. It covers, and ultimately through this one it reaches to the dendrite, so it reaches to the soma there. Anyway, this is the standard one, how the electrodes are placed on the head. So it's the 10-20 like this is the concept is there. This is the standard one. Through experimentation, these people have come up for that. Means that at least what with one electrode means what you have to identify that the regional centers. You see that different regions will be there. Regional centers should be identified properly, and then only that at the nearby the regional center on electrodes are to be placed. How to ensure for that? So that requires for this the 10-20. The formula there. What is the standard formula they have come up with? That specifically that the UC Berkeley or MIT and all this. They have a lot of experimentations that one they come up for that. So okay, so we go for the brain signals. Oh my God. Okay, so this the different brain signals means what it is not EEG signals there. Okay, that shows the different state of the human brain. Delta wave is what? Where is we started from the minimum one is the delta wave is what? Almost frequencies almost sometimes ideally we said that the 0 to 3 hertz or something like that, but a little bit of that. This is what when a person is what in deep meditative state. Suppose somebody is in doing meditation, he comes up for that, he goes to the very low level or something like that. I'm not going for that because I don't know where how many of you are aware about that. Meditation, and not only meditation means what bringing down to the brain signal to the level of that means some person may continue for days without food or without taking anything there. This is possible only when what you bring down your signal or brain to the zero near about. Okay, at the same time organs are to be reduced to that what is the minimum level, so that the energy requirement by the human body is what hibernation, you might have heard of that. Some people demonstrate for that, going in the underground for few days and coming out for that, like this. So hibernation type of that is called that type of deep meditation is what almost very close to the point one, or very that one is hard. Otherwise, what normal meditation that people may come up with around 3 hertz or something like that. In our lab, we have got up to that also 3 hertz. Okay, near about 3.5 hertz. So then theta wave is what? That is what we go for. That is what little bit of slightly higher of that. It's not a deep meditation. We go for that highest. Slightly focus means what it is relaxation. We say that one, the deep is meditation, then you go for the relaxation. If the mind is relaxed, you go for the 4 hertz to 7 hertz there. Little excitation for that. And alpha wave is the awake wave. We want to do all the work and activities there. We go for this one. Alpha wave is the basically is there. So most of the, suppose we want to identify the activities of that all awake brain, activities of the human brain or a person there. We'll be dealing with the alpha wave there. The beta wave again same when you go up the excited and higher level. The more excitation level come up with that, some of the events will be highly excited, which will be exciting that even nervous system higher level. And gamma wave the too much excitation. Some comes the different type of you might have seen that also in that case. Suppose you see that epileptic seizures and others like that. Anyway, maybe tomorrow I will be in the tomorrow's lecture. I will be covering that epileptic part there. I don't know how much level we will be going for that. Then and there we will be discussing about the fMRI together with the EEG part is there for the epileptic that one. Anyway, so in this case here, our case of silent speech recognition. What we did is what that thing is. First thing is what we have to first. Of course, we had to record the data there. So okay. That what are the challenges? We were doing that on the easy data. Wherever once in India, most of the researchers are on easy data only, because this is the cheapest device which is possible. One can afford to that in the laboratory because the fMRI and others we cannot afford. Like even medical college, if it is there, my God, we just talk to them. I had been to that anyway. That Guwahati, that Apollo one neurologist and all this. I was discussing with him regarding the research. And oh my God, horrible! They are too much money-minded also, without taking data and something like. Anyway, they are just fooling people because you have no other option than to go for that one. So because I didn't disclose, I was just discussing like. He was very eager to associate for research with me. Anyway, so that why it is very easy that when you are dependent research only on easy data. That means what? Why it is very challenging? Because the data is highly variable and noisy also. It is likely to be affected easily by the noises which are developed internally or externally there. So that is how. Another one is what the variable in nature. So quite highly random variations there, and so it is very difficult to capture that that the number of patterns there for the across the whole dimension for that. During the events, that one will be there, and across that one coming up with the pattern. So that pattern means what? That, as I said about the classification, my God, you have to capture the individual patterns for given activities. Very, very challenging, very challenging, because the signal as such is very random signals, variables, highly variable. Okay, there may be artifices. What I said, that one is there. Then no benchmark data is a specific traits of. Okay, does not consider nonlinearity of the problem in classification. Okay, normally nonlinearity classification is that most of the classification tests they are not considering for that nonlinearity. You come up with that something features there which will make the system little bit lesser nonlinear, so that like the classification becomes easier there. Anyway, so what are the different methods it is done? In our case is what? Okay, we have started the project with the recording of the data. Okay, means what? What is the recording of the data? Means the 5 vowels in English and 5 vowels in Bengali. Okay, 5 vowels in Bengali, and the recording itself it is also a tricky that experimental that one. So we have a database of that. We have created for that one is database there. Under the project, that one is there. So first thing is we ask the subject to relax it, and then after that what we just give a presentation of the audio. That one, the first thing is the audio, means A will come, then with the clip means with the sound is there. That sound is there. That both visual and audio will be there. A and visual. Then you will be allowed to fix it on that one. After that what? So it's the 4 second. We'll repeat that one. Then fixation 4 seconds. And after that, we think of we just wait for he starts imagining that one, same one there. And remaining 5 seconds, he'll repeat the thinking of that one. So the question is again, I'll see that one, I'll say that. You know that there are so many questions maybe asked for that here. This is okay, but this is the part which is our information, data information, which is required for that. Okay, this is part is there is the information for that. The question is what? When we are asking the same person to repeat it for 5 seconds, okay? So out of 5 seconds, how many times he repeated the same vowel? That we do not know. The thing is what? How many times repeated for that means every repetition took how much time and all these things. This is the thing. It's very difficult for that. Quantifying that exactly so that remaining. So what we did is the same one from there. Of course, after looking, when we look at the signals, easy data, we can even anybody is shown there, he can see the differences between the fixation state and imagination state. In terms of the signal, one can easily identify for that. That is quite visible. That one is there. You can see that one. Anyway, so this is what there. So O R E. Oh, I is there. O I E U A O. So this one and A E I O U, that one is there. Anyway, so what we did is what this research is what the whole thesis is for the project one. So what we did, we collected the data. Then after that, what we had to remove the noises and artifacts. What are artifacts? What are artifacts? Artifacts are also one type of noises, but they are different than other noises. Artifacts are what which are generated from the within the patient or subject. That means what when you are thinking for that, if eye movement, eye blinks are there. Eye movement or eye blink. When the eyelids are quite open and closed and all this is there, immediately you can see that. The EEG signal, you will find that there is a sharp changes for that. This is what you see that there is a sharp change. The sharp change will happen to that one is there. Okay, so even eye movement also will give it sharp change in that one. Then there are cardiac pulses also because it goes on like that is there. And any muscular movement. Suppose that bite teeth, you bite teeth, immediately that will be coming for that. So anything means what that the subject should be in the dormant state in terms of the physical one, other than the mental activeness or thinking of that one is there. So, but it may not happen. You have a subject is that you cannot make it. Sometimes subject is not in a position to do. What we do is we have to have a method which will automatically remove all these things there. So we came up with that new methods, innovative methods for removing all the type of muscular artifact, eye blink artifact, eye movement artifacts. All that one is there. That is what there. And when we have used that one, we have used that as I said about that one. Support vector machine is used for that identification of that. How do we do? How did we do is what? Suppose okay, this one is okay. So it will be clear from here. What we do is here that one whole the signal will be what passed on through a windowing process there. Windowing process. So windowing process of suppose 0.5 second. 0.5 second. No, 0.5 millisecond, that one is there. 0.5 millisecond, the window is there. So through the windowing that one, we just capture the data that whatever the features for every window, then whatever the signals, it is a what. So the windowing will not be sliding, it will be simply jumping. First one, next window like that. So window wise, we calculate the features. Features you might have seen also like the mean, median, mode, standard deviation, entropy, that log tromel and that 5 or 6 features were considered for that. That also I'll just tell about that. I don't know the permits. That also is a funny thing. Anyway, I'll see that. I'll just say that what is being done. That is what we have done. Everybody has done. We have done it. We have come up with the better results than other one. We got publication, but still I'm not satisfied. Okay, the process is what you have this one. What is done in this case is the signal is passed through that one. So windowing, that process is given. So every window we calculate the features, and the features are given to the SBN or the classifier. Means what based on the classifier, it will see that the particular window is corrupted with the eye blink or not. As I said about that artifact removal. So the moment this is captured, means this window is corrupted. It is classified as identified as corrupted one. What do we do? It is passed on to denoising autoencoder. We just passed into a autoencoder there. That autoencoder is trained with a clean EG signal. So when the autoencoder is trained with the EG signal, clean EG signal, automatically what the corrupted part will be replaced with the clean EG signal. Again, next one window. So it ultimately only corrupted part is separated, and whereas non-corrupted part is undisturbed. That means that way, so the modifications in the signal becomes to be minimum. So nobody has done it. So what they have done it only that windowing part, not separating out, just going for that. Or some people they have gone for that even ICA or even that PCA and other type of analysis part there. And even weblet features there, weblet transfer features also. There also they have not separated the windowing part. We have considered for windowing part there, and here based on that we could come up with the results which are it is demonstrated for that. This was proposed method. This is the weblet. Then see with other methods we have compared. For the proposed one is what the RMSE is what that root mean square error, that one is what 0.024, whereas that one accuracy is quite higher for that with that proposed one. That classifier, this is of course classifier for the SDM one, okay, that this is there, whereas for this one is what with that overall that part is there, because this is after the cleaning of that one is there, how much is the error with respect to the original signal and corrupted signal or corrected signal. That is the comparison. So that also, this also is what there is a go for that SR comparison. Okay, so higher is the value correlation with the original signal and the rectified one. If the original rectified one approaches to the original or exactly like here we find out the cross correlation, that one is we find out it should be ideally 1. But with the other method they come with the 0.85, we have come with the 0.89 or even okay, that is what. So anyway, the idling removal, okay, this one is what, as I said about the LSTM there, okay, same one, the idling removal, there is another method because one has to do the PhD work, okay, some more different methods. This is another one, okay. Previous one was SBM plus SBM was the classifier, and DA, denoising autoencoder, was used as a correction one or rectification of that. Here same way we have come up for that one is what, again in doing sections there. So what you see is here can and is k nearest neighbor, that one is the classifier for that, and then we've gone to the LSTM, that one is there. And LSTM probably I'll just see that I'll just go for that for last part there. When I go for that is the LSTM, that is the long short-term memory is there. It is a higher, better version of that RNA, and they go for that, means what it is both local as well as global features are considered for that. So purpose is supposed to be far better. So because of the deep learning, that LSTM, that one is there, we have considered for that. This is one of the very important method approach for okay, I'll discuss about what are the limitations of the existing or standard LSTM and all this, what other new things one can do of that one. So here also, okay, we have got better results, and okay, that is what this is the signals there, and ultimately what okay, I think was identification, okay, that one is there. Okay, this part was the corrected one. You see that this is, I think that one is there, or that one is the corrected part. We see that one is there, and this is the muscular part. This eye blink is quite sharp. Muscular part is what higher amplitude, but frequency is quite higher. And that eye blink artifact is what only sharp. The frequency is very less. Sharp pulse like that is there. We come up for that is there. So ultimately we could rectify. That this both are there. Ultimately we could rectify the sigma. The black one, or maybe is what this part is the rectified one, comes up for that. Anyway, so this is the different methods. Okay, this is again one work we did. It means when we are doing that one, different type of trials are there. That means we wanted to find out that out of the, we are taking that one, we have considered 64 channels. We didn't use 128 channel, that one Egypt. That same machine we used in 64 channel mode. We use 64 electrodes there, and based on we have captured that one. The question was what? That out of the number of electrodes there, every electrode will be giving a channel signal, so that we'll have that one. Now the question is what? Which are supposed to be given, more weightage as compared to the other one, so that ultimately given classification task is more. So that suppose that also this is an optimization method or something, optimal matrix, how to come up with that one. So which trials are to be given more important for that. So in that case, what happens here? That that also manually doing all this thing, 64 channels, or even out of the suppose 25 or 20 are, but the very relevant part is there. But the thing, how to assign the different 20 weights? Simply it is text to impossible manually is what very effective there. So that for the simultaneous optimization of multiple weights or multiple parameters, the best option is what meta heuristic algorithm. This is what we have used for that. That first we started recorded signals, then we have removed the noise through the different filters other than artifact. Then we have come up with the algorithms to remove the artifact, so that now we are modified and artifact free, noise free signals are available, okay, for analysis, subsequent analysis for the our silent speech. But before that means for the electrons also we wanted to improvise that one, so that our analysis part, classification accuracy, in that case we wanted to concentrate, means what instead of number of channels there, we wanted to come out with the which channels, which signals are most prominent to be considered for the final analysis for silent speech recognition for that. So that is what we have gone for. So 3 algorithms are considered for that. I'm not going for that. Actually, this algorithm, what is this? How to evaluate this algorithm? For evaluation, we have used the classifier, LDA, SDA, and all this. Because the development of classifier and LDA is not our achievement for this work. Our achievement is what? How to obtain the optimal set of weights. So heuristic algorithm there. So the different algorithms, so the ultimate accuracy improves for that. That is what there. So in the rest, of course, in that case, 2 type of classifiers are used. We have observed that that is what we see, that what was the comparative results we get, we obtain for that is there in between the LDA and SDN there. Okay, I'm not going for the case. This is okay. This is the different way it is given for that. Okay, so what is done in that case is now we started focus. Okay. So what we have done is, okay, we have used the CNN with the activity map. Activity map is what our concept there, and we have come up with that. These are all the deep learning. You may be knowing about that. The deep learning algorithms there, and I'll tell about that. What are the? So we have done it. We have got papers and we have got the papers and that better results. Okay. So anyway, again, I have the resentment because of this. That people have done it. We have also done it. Chalo, we have got better results. Good enough. So publish the paper, get a point. What is this all? Anyway, because of course the question is that somewhere one has to start. Because once you do not realize basic things, there is no chance for improvement. So there has to be a vertical, movement of that. So it is not shallow. It has to be deep. It is not deep learning, deep thought process, deep physical understanding. Deep physical realization means what? Try to understand the physics of the original process. We are targeting for that is the brain activities, means which are nothing but what in terms of the neuronal responses, and what are the things which might have been happening inside that, how much we know about that, and how to get the information about that, and how that physics is what linked with that CNN. Is how much it is appropriate the tool is for that are the things. Oh, many of you may be knowing the CNN is what. I'm not going for that. Why not other shallow neural network, MLP and others. See, convolutional neural network. Many of you may be knowing for that. Why one should go for the convolutional neural network as compared to the multi-layer perceptron or neural network, back propagation based that. Of course, this is also back propagation. You should not say that one. That this is the BP network. So MLP is a BP network. What is that? This is misnomer. This is wrong. That one, because that is BP is an algorithm there, which is used not only for this MLP, but also for CNN, but also for even other type of RNN and all these things there. So what is this all there? Okay, so CNN is what basically that also it has to have. Okay, why one should be instead of number of hidden layers in MLP, you have the n number of hidden layers. So that should be similar to the CNN. The CNN is having number of because deep neural layer. It's a deep. You have the deep means what in between input and output layer. You have so many more layers. So that makes that the depth of it. Okay, is it the meaning? It's not only that. Then you go on adding that hidden layers. Then that will make it. No, there are some other issues there. Anyway, that is another part some other time. If I find it something like this, Okay. So of course the CNN is what you know, that also that is where the convolution part will be there. So how the convolution happens there in terms of that one, you have the image is not image, basically image is the matrix. So you have any data which is in the form of matrix only, then we go for convolution operation. Basically is for the filtering action. Filtering action means for extracting features from filtering action in the convolution neural network is there. Okay. So now the question is what you have brain signal. If we would have used fMRI, then we could have used this is because that is fMRI is an image. Whereas in the brain signal, it is a temporal signal. So very random and temporal signal. So how can you go for that? How can we use that one? It is not an image. So what you have done is what that activity map is there, which is designed to novel feature of the activity map proposed in the classification. What is done is that signals are converted to some feature map there. That is activity map. Which are the images? Which are the images? Basically that one. So that one is used to be, that is applied. This is used for as an input to the convolutional neural network. So there is the image form we come up for that one is there. So we have each signal, the temporal signal is converted into the activity map, which is basically image and is used in the convolutional neural network, and then come up for that one is the classification of that, come up for that. It gave for that. Another one was stacked encoder there. Stacked encoder is another deep learning that one. So what is, okay, I'll just go for that is there. This is what activity map. You see that one is there. So you know that the color spectrum and all these things are based on that. In the fMRI, you go see that one is there. You go for that, higher and higher means the colors, changing that one is ultimately what spectrum is also saying that one frequency of that one is converted to that, color images. Then it's the activity map. So there is a process for so this image is used as input to the convolutional neural network. Okay, so different type of, I'm not going for that, it's a different type of, I could have gone anyway. Then only this one, then okay, I can explain it excellent way. Every part, what is that, what are the limitation, different type of course, what are the, I could have gone for that is how one can extend the same work in the different direction. Because you see that one work on one type of issues, one will never come up with excellent, structure. First thing you have to have a structure which is the optimal structure. Okay, then on the given structure, how the parameters are to be tuned. Okay, in all the cases of convolutional neural network, back propagation algorithm is used. What is back propagation algorithm? This is a gradient based algorithm. It is very, very inefficient in case of highly nonlinear systems. And some of the students also, my students, they worked on that. Like even MLP or other type of neural networks there, instead of MLP, instead of using back propagation algorithm, they have used the meta-heuristic algorithm. All results were excellently better, excellent, far better than BP based algorithm. So this also you are using that one is there because that is demonstrated, right? BP algorithm cannot compete with what highly nonlinear systems there, and it cannot do simply. It will get trapped in the local optimum. Anyway, that is what we have done it. Okay, people have done it. We have also done it good. We come up with a good results better than other people. Okay, so they've got a publication, these and all this. Okay, that is what there. So this is how we obtained that one is the Bengali as well as English. I think there should be English for that. Okay. So auto encoder, stacked auto encoder is what. This is also standard stacked autoencoder. Again, as I say, it means I am not satisfied because you are using that. This is also gradient based method that used for the optimizing that one. What we do is here in that autoencoder, you have that input of means high dimensional input is there. Then you reduce that input to ultimately 7 neurons. How would it? This is what we decide of that how many neurons we should come up with. That this experimentation has to be there. There may be some algorithms or some methods which can be evolved so that which can be effective way of coming up with this one is there. But suppose in our case we want to have that 1 to 5 vowels there. So that's what we have come up with that 5 ones there. Here, so not the 5 that's or lesser code is there. Lesser number of neurons here there. And from the 64 to it is brought down to that one in the different level 32, then 15 or 20. They come up with that. That is it is called stacking of that. So what is done? The process is very simple. So this every layer with the reduced neuron subsequently, and you are connected with the neurons weights are there. So how do you do this one? Is we go for that. What the process is one? Here we go for 64 to here. Suppose it is 7. That output is here, and from the 7 you come up with again opposite way. 7, 20, and again 64. So this 64 output should be ideally same as the input. So that now you gone, so then you compare. Initially output will not be same as the input, so gone finding the error, so there will be error. So error will be used for optimizing the or updating the weights, specifically one sided, this weight. So once you go for that, updating the weight so that the error is reduced, when the error is almost zero, ideal zero, by almost zero, that means that these weights are what they are the optimal weight, and these weights are supposed to be just opposite to that. One can come up with that also, is there, can be done. So because it's just opposite part, this is encoding part and this is decoding part, is there. So a decoding part is just opposite to that one, is there. Okay, so what is done is what, now the question is what, we had so many features there, the five, this one is there for the different channels, different type of parameters, so the features we were considered for that. So 7 to 8 for each channel, then come up for that one of, suppose the 64 channels, out of that what most prominent one, 27 or 23 I think channels are there, the trial selection for that, and out of that one of every one multiplied by, they have the 7 to 9, 8 to 9 that features there. So you come up, you have the feature input there, it is reduced to that one, reduced one. Why the question of reduction of the feature dimension? This autoencoder is highly used in for reduction of the data size, data compression. It's a very efficient method. And some other research scholar, he has worked on that. In this research thesis, we have used the conventional gradient-based method there. Another scholar, he has used heuristic algorithm. He has got far better results than gradient-based method. It's already you have got the results there. So that is how we just see that one. So anyway, that here, so we have come down to from the number of input features, they come down to the lower one there. So this mapping from the higher dimensional input to the lower dimensional input, that mapping is non-linear mapping. If there is more non-linearity, gradient-based method has to miserably fail. This is tested one, everybody knows. This is the fundamental theory. Anyway, the process is what you can do it there. So this is very, if it's the knowledge you want, then okay. So this input, mapping of the high dimensional input to the low dimensional output here in between, that one is there. So once you can do it there, so ultimately with this one, the concept was using these features, then we want to what? Using this lower dimensional features there, we have used that classifier for softmax there. You can go for that is there. This is the last one. Go for the lower one to 16 with that. So ultimately was 64, then 32, and then 60. As I said, 7. No, it isn't 16. So we have come up to 16 there. You can come down to that also. There is nothing for that, even 7 or 8 or something like this there. Okay. Then after that, what? That 5 that you have the 5 classes for that one is go for that. This one is for Bengali, separate autoencoder, English is separate. It has to be training has to be different for the different languages. So we have come up with that. So the 5 classes are there. Softmax, that also is from probabilistic one is the most effective one to come up with what probabilistic, better results of that. So, probabilistically higher that one, or more prominent one will be considered for that. That is how it is done for that. Okay, so this is the results. So you have come up with that various one of encoder for that for different languages. How much time left? Okay, I can take 5 minutes, not 5 minutes, 2-3 minutes. Okay.
Yes, sir. You can take, sir. Yes, sir.
Okay, so this is what, because I wanted to go for add some more, maybe not today, some other time. So tomorrow's lecture I will see that some more, because I didn't have time to include so many things, because it is not that, because right now thesis he is going to submit in the 3 days time by this scholar. So final stage, I was checking every day, every 2 days, one chapter like that. Another thesis from electrical student, he is also going to submit that within 10 days, 12 days time. So this is so much in the simultaneous coming up with that, so many things there. Anyway, so so this is RNN. We did not use that RNN. We have used that LSD in there. RNN is of course very appropriate network for specifically for identifying time series, time series analysis, or that different type of response and other like based on the time. So many time series data will be there. In that case, with respect to time, that the data is different, the values are different there. So we want to capture for that. We go for this RNN is there. So RNN is what, of course, this everyone is this is a neural network again, local one that you have. So you have input, the local one is there. Then again from their output to be coming for that. So this is gone, that's there. So you come up for that. There is a recurrent. So it is actually there has to be feedback again. So this is not given for that. So there has to be. I've not included folder, something like that is there. So that means what here training of this one is mostly on its local, input. So it will do repeatedly that updating of the weights, no, updating of the go for the repeated part for the given one is there, okay, that one. Then again you will go for that one. So this output will be coming for that. Again there will be this neural network, and it's concerned with its own output, okay. Then you go for that. So ultimately what when it comes up from here, so every data response what means, or with respect to means x0 is at t1, x1 is t2, x2 is what t3, like that. So at different time, so that we are training that neural network with base local information. So that is why it is what recurrent, okay, that the network is what being repeatedly that one that being trained. So that so ultimately when it comes up from here, every part, the whole channel part, there you have a sequence of that one, and you just come up with that, means what is the output there. And from there means what, again this is what that algorithm for tuning this weight is also gradient based, that one is there. That is what I say, that one is what if the relationship between input and this output for the every part, that one with respect to the neural network, if the relationship is maximum nonlinear, means maximum what quadratic, that's a hyperbolic type is there, then of course derivative part, even not this, to some extent at least what you are likely to get that optimum one. But if there are more than that one is there, nonlinear is more than that second order or thing like this, no way, you are not going to get that. You are not going to get that. So one has to use for that. It's not like that. One has to go for. So this is likely to give. So even if it is there, so whatever results is with the given standard RNN it gives, it is a suboptimal result. It is never global optimum. No way. No way it is there. So whatever applications which are being applied for that, or tested or applied on a given applications there, or given problems there, same one that if you go for that, because you have done it with the whatever till now it is reported means what with the local optimum RNN, okay. Now similarly here, okay, that is okay, there is not more things there other than the application of meta-heuristic algorithm for optimizing the weights there. But when you go for the LSTM, you see that LSTM was considered for an upgradation of the or for what overcome the limitation of RNN. RNN was what that is more concerned about the local features, the local information. You train it there. But it's not given any importance to the sequence of that. From here to here, what are that? What is that? All these things are not given important. Okay, so for some cases means what that is also very relevant for that, because too much localized tuning for that one is may not, because you see whatever when you train that RNN, when you do it localized one fine tuning, so it will perform excellently on what training data. But with the testing data will be slight differences there, it will be definitely it will be suffering that one. Performance will suffer like anything is there, because it is locally optimal, that one, and which was mainly centered around the training data. When the test data is supposed to be different than training data, where 20%, 10% variations, you are supposed to have the different results. Okay, that is what. So because of that, here means what you are not, we do not consider there the previous, because it's the time sequence, the time sequence of that one is there. So to overcome, because the local features there, how to include the global features there, other than the local, some global features are to be considered for that, and that has come, that is what long short term memory means. It is long again short, because we said that it's long again short. Why again long and short term is okay for me? So means what is the memory is there. That means what there is what the memory means, what we have to think of anything. The memory means which is the past information. It will be past information there. We have that one is there. So you want to have that long short term is the whatever the past happening and other things. So in that case, no, we want long, but not very long. It is a long short term. That because it has a limitation in the coverage of that, in the getting the information of the past one, means global. Past means the global one. So now it happens that that you might have seen whoever have worked on that LSTM, you'll see that different type of input gates there, the forget gate there, output gate. Oh my God. So the question is what? So many parameters, you see that. And in between you have the memories there, and then ultimately what? That this input gates together with what? Whether you are training this one, this is also based on gradient based algorithm. The training is. So when you are, why the training? To what? Optimize the weights. So weights, what about the gates? Gate means what? What are the values? Suppose I say the 0.6 is there, forgetting that what is the 0.6 factor. That means what? That how much we consider for that, how much percentage of that forget means we want to forget, and how much should we retain? So the question is what? When you have 3-4 parameters which are to be tuned simultaneously, can you do it mnemonically or manually? It's horrible. At the same time, you go for tuning of the optimizing the weights. So even without, because we have not considered till now, we have not considered for that one is there that we have considered standard way, whatever people have worked in that we have done it. We have got better results. So it is what you apply this one or to some field where nobody has applied. The first time you are applying, okay, it is an innovative application. Good, you get a new publication and good work and journal and all. What is this all? I am not interested for that because I know I have done so many things. Now I am not interested. So anyway, so next student will be working on that this year is how to make this still. It is not local optimum. So it's a gradient based. This one will be always a locally optimum LSTM. It is not global. When we go for the heuristic, meta-heuristic based algorithm here, not only weights but also all these gating factors also will be considered for that. Even one can go beyond that also. You see, I'm just talking about the new generation. I am concerned with new generation people, new generation student, and something like that who are really, who are committed and doing something new or something more, something relishing. See that. I feel nowadays it is something like what is that? You take every day same food, same menu. Don't enjoy like this. What you do something that means what which gives a feeling to you. Yes, you are on something like this. Sensible. You may not be able to do everything in that way. That impulse or something. At least do something by 20%, 10% you do that. That is satisfying or something like that. That is what they hope that means what the key. Okay, that is that one. Thank you.
Thank you, sir. So thank you very much for sharing our profound knowledge with us, sir. And your session was full of valuable information, sir. Sir, we have a couple of questions, sir. I want to share.
Okay.
Sir, may I request you to kindly stop the presentation, sharing the presentation, sir?
Okay. Okay, I've stopped it.
Yes, sir. Is it visible, sir?
Oh, no. Wait. Oh, questions, no? Is it?
Yes, sir. Yes, sir. Questions, sir.
Okay. A bar, huh? A bar. First one.
Yes, sir. Yes,
what
sir.
kind of signal conditionings are used for analysis simulation of such signal? Okay, signal conditioning is okay. Signal conditioning may include many things there, but okay, this is suppose that is the internal part of the equipment there. Some condition. Suppose you want to know that augment the signals or something like some whatever the signals input there, it will be in the microboard, the mini board coming up with the 5-volt and signals and all this. That is what it is not in our part. The machine gives us, but our part signal conditioning includes is what some of the noises. Some of them, that one I have seen about that more than 100 hertz, more than up to 100 hertz EEG is there. So beyond that one is not there. So we have simply cut off that. Beyond that 100 hertz, it is what simply it is cut off there. We have simply the block that one more than 100 hertz, and in between for the power signal 50 hertz, we have used a notch filter to provide for that. Rest is almost not many more things are available in that one is there. Okay. How to distinguish between seizure and okay, tomorrow's class, if you happen to attend my tomorrow's class, I'll go for that, because that I was telling about that. My God, that when I was talking with a foreign professor, See what is the difference between even aims, because I was having a look into that, what are the aims, professor, they have been achieving with that. Not aims, the NVRI, National Brains Research Institute. What is that and all this there? You just look into that, you can see that what are their achievements. There's in India only one, and one is the neem hands. Neem hands could come out with that. In the neem hands, some works are getting done on neurogenesis. I don't know whether you have heard about the neurogenesis. That self healing of the human brain. As I said about that, there are revolutionary ideas and areas and all this where one can revolutionize no hand. Oh my God! Because I am a student in this. Means what? Because this is my passion. No question of retirement and nothing like that. Till I die, I will continue in this area domain. So my fundamental research will start even beyond that also, like this when I retire or something like that. Because this is something like that, it is passionate and one can really contribute significantly to the society for that. So what they did, that the professor, when I was discussing with that neurologist at the Apollo Hospital, Guwahati, I told him that, what are the things, that how do you use the signals? What type of signals do you use? He said, no, we don't use any signals. If the patients, they have their own fMRI and other type of, that from somewhere, something like that, we just ask some questions based on that one, some abnormality, all these things there. They prescribe medicines. What are medicines? Oh my God. What medicines are there? All sedatives type. It is not a real treatment unless you monitor and all these things there. And whereas, that when I was talking to the foreign, very within 100 rank, world ranking university, that one in neurologist there, he was having so many whatnot, fMRI, EEG, TMS, everything. And he was talking, we have submitted a project there. But because of, I think, Corona, otherwise I would have been there in that university by June. But that because of Corona, I don't know what will happen to what will be the fate of the project. There, that professor was, the way he was interacting with every patient, monitoring whenever they come to that center, they go for retaking that signals and going for that one, all this monitoring that one properly. And when I wanted to write a proposal there, it was really learning experience for me as well as him also. He was a doctor. I told him that you tell me that what will make you as the best enable or capable doctor to treat your patients. Just think and tell me, and then I'll think of that. Means how much I can help you. Means what are the things you should know? You want to know about that one brain, and what are the other things there, and then I'll think of that how much of that could have been can be made possible. That is how we started off the interaction. We came up with not only 1, 2, 3 types, specifically that one epileptic, that one ASD, autistic, that one is there, and then I don't know, Tourette syndrome. You may see that one in the net, or Tourette syndrome. Anyway, that is the different part there. Anyway, I don't know if that project materialized, then we'll come up with that. That is not, that both MEG and EEG, so that one, as I said about that one is there. The precision is what, how do you go for that? You go the higher and higher, that depending on the electrodes, placement of electrodes, that one 128 and 256 also it is there. That it was coming up something more than 1 crore, 256, that one. Geodesic, company is the famous, that one. They were having that anyway. So like that type of things, that MIT and specifically UC Berkeley and all this, they have come up with so much level, micro level. They have already developed micro sensors, not nano is there. Then that coming for that one is nano sensors, that one, and to penetrate into the human brain and targeting that means for every of that one, specifically Alzheimer's disease, the Parkinson's disease, and all this, that type of thing is there. They're working on that. We cannot do that one unless and until you have that facilities are there, and should be dedicated researchers going for that in that way. There. Anyway, can you provide informative resource to, okay. You have, I think I have given my email or something like that. Then you can share, and I can share that. What are the different things available for that? Is that possible to feel like human beings completely by that technique? I don't know what technique. By what technique? I don't know. Is it possible to feel like human beings completely by the technique? It's artificial technique? I don't know. Okay. You see, ultimately you have to understand that it is a machine. It is a machine. We want to translate it to behave like a human being. Suppose it's that a robot is crying. Oh my God, do you think that one is, can you make that, you change your feelings there, and that maybe what that feeling of the robot also can be made innovative. means what? Evolving. But the thing is, evolution of that one, that synchronization of the evolution of the thought process of that robot and the thought process of human being. Can you synchronize? Who will synchronize? Every human being thought process is different. So you cannot generalize. You cannot come up with that every human being there is a separate robot. The one robot for Nidul Sinha, another robot for another one. Oh my God, simply not possible. So it is really challenging. But you have to think. You should one thing that you should never think impossible for that. Whatever impossible you are told about that, you have to drive on that. See that means what are the hurdles, and tactically, reasonably you approach to that one. Can heuristic algorithm knowledge systems are applicable to brainwave signal? No. Heuristic algorithms are basically is for optimization. So suppose that in the channel we have number of channels there, and which one is to be given more importance means weights. So that simultaneous that one can be done. So any sort of optimization where huge number of parameters 200, 300, 500, there is no limit. Any parameter you want to come up with the optimal set of values for huge parameters represented by in a system representing a system is a highly nonlinear system. Only solution is heuristic algorithm, meta heuristic algorithm. No other algorithms will give you that. You just go for that what we say that one that in the civil they go for that some other linear that one go for that discretizing of that one what is that they say that that also is what localized linearized that one is there, whereas heuristic algorithm there is no limit, nothing like that is there. But why the spatial resolution is too limited for easy signal? Because we did not use that so many electrodes. We did not use so many electrodes there, because you got, as I said, 256 electrode that one. The resolution is higher, but the thing is it's very costly. As I said, India government, we accept for 49 lakhs, they were coming down to ultimate, they came down to 25 lakhs. You see, you are demanding for 70 rupees per kilo milk, and somebody will come that, can I have it for 40 rupees? I'll say yes. But can you think of that after some person will come and they'll say 20 rupees? Yes. That means what? Original milk, same one, whatever 80 rupees is there, I'll add one more liter. Then what? 50% will be milk, 50% will be there. From there, I'll give you that one, 40 rupees that one. Again, 20 rupees means I'll add some more water. Milk remains same. You see, these people, I don't know. First thing is government should say that they are not in a position to support. It is not political solution. It is a technical solution. Which you cannot support. Yes, if you give me something, I was telling about it, give me something. End of the day, if I cannot make it happen another way, like there is lacking on my part, I'm ready to face. I'm ready to go to the river bar behind bar. Yes. Even till today, I can challenge that person also. That type of, because other day also I was talking about that also. Even who came up for that that one CDEC, that one from the Trivandrum is the top boss of that CDEC, I think. The most top boss of that one is. I was telling about that. Anyway, I am not going to the finisher. What are the success rate is maximum 20% optimistically. 10,000 crore suppose. Don't forget about 1,000 crore, including IIT. It will be 10,000 crore every year. You see that for so many years. So 1,000 crore suppose fund is given. Out of that, 20% is the maximum, or 10 to 15% success rate. You understand? 10% success rate means what? That only 100 crore is properly utilized. Rest 900 crore is what? It is a loss. I completed 3 more projects there. Nobody asked me. Government never asked me whether the whatever objectives that I submitted for the proposal. Nobody asked me about that. Means what? That why? What was the objective and target, and could you achieve it? If it is not, what was the problem? I'm ready to say. They will not ask, because I have not committed anything wrong. But it is never asked nowhere across the country. Even including the CDEC, that professor was talking about. I just told him like that is there. Can you share me? Then he was just like that other way. He was just looking at me blank. So which cathode is required for equilibrium? It is not cathode is required. You just electrode is required for the equilibrium signal. Simply the electrodes are there. Electrodes are simply electrical conductor type. That one is there. So there is a separate one that which is placed. So it is modified for placing on the skull. So the resistance between that one skin and that one, we apply the gels. So the conductivity, that gels are made of the conducting material. Gel is there. So ultimately what? That conductivity increases. between that screen and then below the screen, and then your electrode. Electrode is basically is made of conducting materials only. Ideally, what it should be gold is the best one. Otherwise, you got a silver or copper. This one. Can we have brain stimulation between two human? That is what going on for that. USA is what Berkeley and the MIT they are looking for. That is there. It is maybe in future we have to target for that, because in future you see that these are the areas. Even if the fighting is there, you have to. There will be mind games in future. 20 years, 30 years down the line, who are the students now? That will be your lifetime, and you have to face this type of that. Even you will have very complicated diseases, complicated that defense system, this type of things. This will be totally mind game there. Where what? But we should not be laggard. Somebody has to start. And what is the term? Oh, bipolarized disorder. You see that? That is the other day I was talking about that. I was talking bipolar disorder. Oh my God. I know this is what psychiatry is. I feel that some of the psychiatrists that themselves are what highly bipolarized. I know one or two are there. Oh my God. You see, bipolarity is what? It is inherent to everyone. It is inherent to everyone. You see, what is the meaning of bipolarity? Means what you have, that one is what? Two. One is positive nature, characteristic, other one is negative. So everyone is supposed to have that. You may be switching from one to other. So if there may be too much balance, means okay, it is very, some will be highly positive, polarized, other one is highly negative, polarized, or all this is there. Inherently, everybody is supposed to have. So what you do is what? Just don't distress yourself. Just go for relaxation, relax your mind, modify your thought process. Positivism has to be included in your thought process problem, and then only you just have confidence in you. Because it's just when you have to lose the confidence, so that you are switching into the negative side of that one. Look back, because look back into that the long path you have traversed, overcoming so many struggles. You have come out successful. That will give you that, instill the feelings that you have that one capability and strength to overcome that. Anyway, that is different. Oh my God, we are working in our future direction. We'll be working. I'm thinking to start a club here, which will be a meditation club. It is not there because we are okay. That with the foreign professor, I was talking. We are coming for the number. I don't want to divulge at this moment because this is what some Indians are very apt in making mockery of that. What is that? He thinks he's an expert. I'm not an expert. Okay, I'm a full student. Okay, I'm trying, struggling, trying. Anyway, so I will not divulge. Because still, if that happens there, because we wanted to use the silver mind programming is a mind programming method. I learned all this technique long back there when I was doing PhD in Calcutta under a very professional professor who used to take 750 rupees 20 years back for every patient. Anyway, that is a different process. What brain waves are best for learning? No, there is not one brain waves. There are so many brain waves that is not best for learning is not there. Means I don't know that science, that concept itself, the statement itself is something that clueless or something like that is there. Okay, how to carry out this analysis? Can you go practical use of software like? Yes. Where is the MATLAB only? Okay, so can be done. And MATLAB also we are using. Everything is done. Okay, some of that new one they are working with the Python, because Python has got what that basically not only that, because heuristic algorithm, meta-heuristic algorithm, because so many works are already done on that one. So on the MATLAB base. So out of 4 research scholar, one is submitting that one within 3 days time. Then other 3 are working on that, means based on the Python that one. Some part partly MATLAB, partly Python. Are Baba, that filter is okay. This is not filter actually. CSP is a domain of the features at that point. Go for that. It is a particular paradigm that most of the people they have used for that. That they have used that is there. Of course, the thing is what how much of that, because you come up for that. Specifically the frequency related signals, when you are the frequency spectrum keeps on varying up, that in terms of the frequency spectrum there, and this proves to be more effective in that sense. So that is why it is used for that. But as I said about that in our work also, these are some other features. Okay, I was saying about the mockery of that. You have a random signal. You use that 7 to 8 of features there. That mean, median, mode, standard deviation, all these things there. Entropy and all this. What this one? These are the parameters for random signal for identifying the dynamical process there. So highly dynamical that one. Oh my God. Dynamics is what? It is not only the mean, but the thing is variation of the different data in what sequences. That is more important. That is not carried over by the mean. Standard deviation. What is that? Standard deviation is a global process. It is not time domain information. Temporal information is lost. But we have not used that one. Oh my God, I want to know what I induced machine learning. What I induced machine learning. Oh yes. That is what no, some level you can do. Right now also you can do that. That can be done. That is what the BCI. BCI application, they are doing so many, wheelchair movement and all this thing. You can see that one. Oh, I have not added for that one. Is Stephen Hawking, that one. What he used to do, he was just gazing at that. You have to have a number of, that screen will be there in front of him, and he was just gazing at the different letters. And just from gaze only, that letters will be selected. He was forming the words, and then word was there, sentence was created, and vocalization was done. Software. That is how he used to deliver talk. That is not big thing there. Just gazing at that. Just you have the camera, and it can be done. Okay. What is this? Is there physical method to reform laws and no? This is okay. This is the area. Artifact removal is the research area. So there are so many methods there. That I say that my even PPTs also may have some parts will be there. Can we have a quantum state of technology to identify? Yes, yes, everybody is looking for that. Means what that eco technology is the reality. Means what Japan they have come up with that. Taiwan they have been working with that theoretically, and they have that nanotechnology very well established labs. Many universities that, of course, as I said about that, UC Berkeley, they are having their MIT also. MIT just very huge funding is done to come up with that nano sensors placing inside that one. Actually, that starting the behavior of the neurons also. Alzheimer's disease and Parkinson's disease, they want to go for that neurodegeneration. As I said about that means, that neem hands, they have come out with neurogenesis. They have used the stem cell. And I don't think it is very tough. Stem cell. Anyway, that is okay. There people are working on that. Unless you have that neurologist expert and other like the neurosurgeon or something that they cannot do research that way. There has to be combined team effort. Then only it is possible. In India, very few places it can be done. Some are saying about that. CDEC Trivandrum is asking me to collaborate, but the thing is it is very far. Trivandrum is too far, equivalent to going to even some foreign country also nearby. So it is anyway. So that one. Can we have content? Okay, that is where how to convert these signal to image. No. You know that also image can be what you have. That is what I said that our that one. That new features in terms of the image domain is there. You can have that convert that image in terms of the image. The signal is in terms of the frequency spectrum. Then you convert the frequency spectrum to the image, corresponding image. So you know that also what that the frequency higher means what will be that color of that. And there's a color image. Basically, it's a color image. So every frequency spectrum will be assigned a color. Then you have the combination. That's what it can be done. How many hidden layers you have used in your project and which activation functions? No, most of the cases. No, there are many. This one. In the SPM, it is what the RBF function is used, and in the that one LSTM, that one normally is the standard that sigmoidal function is used for that. Sigmoidal function is used for that. What software is recommended for this type of signal analysis? No, as I said, we have been using that MATLAB only. That's okay. But as I said about that, because that Geodesic and other company, foreign company, they approach for that. They have lot of analytical software. They provide with the equipment. We didn't have. We could not procure that one, as I told about that, because funding was restricted to 50% of that. Anyway, I just thank you. Thank you.
Thank you, sir. Sir, once again, thank you. We are looking forward your same support in future events as well, sir.
Okay.
Thank you so
I'm
much.
very
sir.
much thankful for the organizer to give me an opportunity to share with the new generation people. Because as I said about that, this is my area. It's my related to my heart and passion. The passionate area is there. Even if it is not related to my service job and all these things there. Not retirement, nothing like that is there. It's what probably after retirement I may be going for some fundamental research in this domain. Already that things are coming up, ideas are coming up, projects are coming up. That doesn't require some other way like you see that one. Thank you very much.
Okay, thank you so much, sir. Thank you. Thank you. Participants, today we are come to the end of the second day of MLCV 2020. Tomorrow we'll meet at 10 a.m. on the same platform. So have a nice day. Once again, thank you. Namaskar.